Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, good afternoon, and salam sejahtera bagi kita semua. Yang terhormat, Ketua SMYAGI Universitas Syah Kuala, Saudara Muhammad Ilham Adiraya Parindui. Yang terhormat, Pembina SMYAGI Universitas Syah Kuala sekaligus Wakil Dekan Kemahasiswaan Alumni dan Kemitraan Universitas Syah Kuala, Dr. Insinyur Bambang Setiawan, ST MNSC. Yang terhormat, pemateri dari BIN, Dr. Engineering Iwan Setiawan, STMT. The Honorable our speaker from Institute of Geology and Geophysics Chinese Academy of Science, Professor Wei Bin, Professor Yang Chu, and Associate Professor Zhang Xiaoran. Penghormatan saya juga kepada seluruh dosen, laboran, serta staf Universitas Syah Kuala yang telah berhadir pada hari ini, juga kepada para undangan kuliah tamu yang telah berhadir pada hari ini. Baiklah hadirin, langsung saja untuk memulai rangkaian acara hari ini dengan keberkahan, marilah kita dengarkan lantunan ayat suci Al-Quran yang akan dibacakan oleh Saudara Muhammad Hardiansyah. Kepada Hardiansyah kami persilakan.
Assalamualaikum warahmatullahi wabarakatuh. A'udzu billahi minasy syaithanir rajim. Bismillahirrahmanirrahim. Ya ayyuhalladzina amanu jatanibu katsiran minaz zanni inna ba'dadh-dhanni ithmu wa la tajassasu wa la yaghtab ولا تجسسوا ولا يغتب بعضكم بعضا أيحب أحدكم أن يأكل لحم أخيه ميتا فكرهتموه واتقوا الله Innallaha tawwabur rahim. Ya ayyuhan nasu inna khalaqnakum min dzakarin wa untha wa ja'alnakum syu'uban wa qabaila lita'arafu. Inna akramakum indallahi atqakum. Innallaha alimun khabir. Sadaqallahul azim.
Terima kasih kepada Saudara Hardiansyah. Semoga lantunan ayat suci tadi dapat menambah keberkahan kita pada acara hari ini. Selanjutnya, mari kita berdiri bersama dan menyanyikan lagu kebangsaan Indonesia Raya. Lagu ini akan dipandu oleh Saudari Meshalia. Kepada Meshalia dipersilakan. Hadirin dipersilakan untuk duduk kembali. Selanjutnya, marilah kita dengarkan kata sambutan dari Ketua SMIAGI Universitas Syahkuala kepada Saudara Muhammad Ilham Adiraya Parinduri. Kami persilakan.
Assalamualaikum warahmatullahi wabarakatuh. Selamat siang dan salam sejahtera buat kita semua. Yang terhormat Bapak Dr. Andus Insinyur Bambang Setiawan, ST, MN, SC, selaku pembina SMIAGI Universitas Syahkuala, sekaligus Wakil Dekan 3, Bidang Kemahasiswaan, Kemitraan, dan Alumni. Yang terhormat Dr. Engineering Iwan Setiawan, selaku Kepala Pusat Riset Sumber Daya Geologi, BRIN. Yang terhormat Prof. Yang Chu, dari Institute of Geology and Geophysics, Chinese Academy of Science. Yang terhormat Profesor Wei Lin, dari Institute of Geology and Geophysics, Chinese Academy of Science. Yang terhormat Profesor Xiaoran Zhang, dari Institute of Geology and Geophysics, Chinese Academy of Science. Dan yang terhormat para bapak-bapak dosen sekaligus laboran dan kawan-kawan sekalian yang saya banggakan. Pertama-tama marilah kita panjatkan puji syukur atas kehadirat Allah Subhanahu wa taala. Karena atas rahmat dan beliaulah kita bisa berhadir pada kegiatan kuliah tamu dengan mengangkat tema Geodynamic and RE Potential of Sumatra. Harapannya acara ini berjalan dengan lancar dan memberikan wawasan baru untuk kita semua. Akhir kata saya ucapkan terima kasih kepada para panitia, dosen-dosen, dan juga para pemateri pada kegiatan kita kali ini. Akhir kata saya ucapkan terima kasih. Wabillahi taufik wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Terima kasih kepada Ketua SMIAGI Universitas Syahkuala. Selanjutnya marilah kita dengarkan kata sambutan dari pembina SMIAGI Universitas Syahkuala sekaligus Dekan Bidang Kemahasiswaan, Alumni dan Kemitraan Universitas Syahkuala, Bapak Dr. Insinyur Bambang Setiawan, ST, MN, SC.
Before proceeding, I would like to convey Professor Dr. Alfiansah Yulianur. He is the Dean of the Faculty of the Engineering, Universitas Syahkuala, and he apologized for not being unable to attend the guest lecture today because he has another official engagement at other place. And even though he cannot attend here, he fully support and appreciate the importance of this academic event. He extend his warm greeting to all the speaker, Prof. Wei-Ling, Prof. Yang Chu, and Prof. Xiaoran Zhang. Bismillahirrahmanirrahim. Let me give small speech in Bahasa because most of attendant here in Bahasa is Indonesian. I'm sorry, but Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirrabbilalamin. Puji syukur kita panjatkan kehadirat Allah Subhanahu wa taala atas limpahan rahmat, taufik dan hidayahnya sehingga kita bisa berkumpul hari ini. Salawat dan salam tak henti-hentinya senantiasa kita sanjung hajikan kepada Nabi besar Muhammad SAW. Yang saya hormati para narasumber, ada Prof. Weling, Prof. Yang Cuyang, Prof. Zhang Zioran, dan Dr. Iwan Setiawan. Kemudian juga yang saya hormati Bapak Ibu dosen yang hadir hari ini dalam rangka untuk menghadiri kuliah tamu dengan judul Geodynamic and Mineral Deposit of Sumatran Island, Indonesia. Yang saya banggakan juga para adik mahasiswa yang sudah antusias menghadiri kegiatan ini. Dari pihak dekanan terus terang juga menyatakan bahwa tema yang diangkat kali ini adalah tema yang sangat relevan dengan kondisi dan tantangan global terkait dengan sumber daya alam. Sehingga kita berharap dari Fakultas Teknik mengharapkan agar apa yang sudah didapat hari ini bisa dijadikan memperluas perspektif dari yang hadir dan menyadari bahwa tantangan-tantangan geosains ini masih sangat terbuka lebar, khususnya dalam rangka pemanfaatan sumber daya alam. Akhir kata saya juga ingin mengucapkan terima kasih yang setinggi-tingginya kepada semua narasumber dan juga antusias dari para peserta yang hadir hari ini. Semoga kegiatan kali ini memberikan manfaat yang sebesar-besarnya bagi keilmuan, kemudian juga membangun jejaring sesama peneliti di bidang kebumian. Saya akhiri, wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih kami ucapkan kepada pembina SMYG Universitas Kuliah sekaligus Wakil Dekan Bidang Kemahasiswaan Alumni dan Kemitraan Universitas Kuliah. Selanjutnya marilah kita mengadakan sesi foto bersama. Kepada pihak Medcom mungkin bisa mengambil alih. Fotonya dari depan ke belakang terlebih dahulu. Oke, mungkin 1, 2, 3. Mungkin bisa berganti ya. 1, 2, 3. Sekali lagi. 1, 2, 3. Untuk sesi foto selanjutnya mungkin para pemateri boleh ke podium. Please come. Acara selanjutnya adalah pemberian cenderamata kepada panitia. Please. Thank you. Selanjutnya hadirin yang kami banggakan, sekarang kita akan memasuki sesi yang paling kita tunggu, yaitu kuliah tamu. Sesi ini akan dipandu oleh dosen kita, Ibu Nazla Syafitri Rangkuti, STMT. Kepada Ibu Nazla Rangkuti, STMT, kami persilakan untuk mengambil alih.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon all. Selamat siang, salam sejahtera bagi kita semua. Yang saya hormati, Ibu Kaprodi Teknik Geologi Universitas Syakuala, Ibu Dr. Insinyur Halida Yunita, STMT. Lalu Wakil Dekan 3, alumni, kemahasiswaan dan kemitraan, Fakultas Teknik Bapak Dr. Insinyur Bambang Setiawan, STM MSc. Lalu yang saya hormati, Sekretaris Departemen Teknik Kebumian Universitas Syakuala, Bapak Dr. Insinyur Gartika Setia Nugraha, STMSI. Lalu pembicara kita hari ini dari BRIN, Bapak Dr. Eng Iwan Setiawan, STMT. Excellency, our speakers from Institute of Geology and Geophysics, China's Academy and Sciences, Professor Wei Lin, Professor Yang Chu, and Associate Professor Xiaoran Zhang. Oke. Dan seluruh dosen dari Departemen Teknik Kebumian dan seluruh partisipan di acara seminar hari ini. Baik, ladies and gentlemen, today's seminar will have dual language, English and Indonesia. So I will combine all of them. Hope you all here understand what we are talking here, yeah? Okay. I'm Nazla Shafitri, the moderator for today's seminar. I'm very pleased to see you here and welcome all of you to this seminar. Today's seminar is about geodynamic and earth elements potential of Sumatra. As we know, that Sumatra Island has active tectonic activities affected by subduction zone in the south of Sumatra. We can see today from earthquake rates that triggers the Sumatra fault zone as an active tectonic. Besides its high potential risk, this tectonic setting produces many potential mineral deposits along this island. In today's seminar, we will get closer into how geodynamic and mineral deposit distribution in Sumatra Island. Let me inform you in brief that this seminar is held by SMIAGI Universitas Syah Kuala in collaboration with Center of Geological Resource of National Research and Innovation Agency, or BRIN. Ladies and gentlemen, our first session will talk about geology of rare earth elements in Indonesia. We would like to invite Dr. Eng Iwan Setiawan, STMT, to the stage. Baik, sebelum memulai acara, ya, kita berkenalan terlebih dahulu dengan Bapak Iwan Setiawan ini. Boleh dibuka CV beliau. Baik, saya bacakan terlebih dahulu. Saat ini Bapak Iwan Setiawan sebagai Kepala Pusat Sumber Daya Geologi di Badan Riset dan Inovasi Nasional sejak tahun 2022. Beliau menyelesaikan studi S1 di Universitas Padjadjaran, lalu Master Degree di Institut Teknologi Bandung, dan Doktor di Universitas Akita dengan mengambil fokus ekonomi geologi tentang rare earth element. Sangat relate ya teman-teman dengan topik hari ini. Lalu beliau pernah menjadi visiting researcher di Guangzhou Institute of Geochemistry, Chinese Academy of Sciences, dan di University of Chinese Academy of Sciences. Lalu mengambil postdoktoral di Institute of Earth Science, Academia Sinica, Taiwan, dan selama tahun 2014 hingga 2015, beliau pernah mengikuti beberapa training seperti di Jepang dan Filipina untuk pendidikan spesifik tentang endapan porfiri, gold and copper, lalu REE di Jerman dan Afrika Selatan, lalu geothermal di Jepang. Beliau telah mempublikasi 79 publikasi dan proceeding untuk tingkat nasional dan internasional, 3 buku, 1 paten, dan 2 rekomendasi. Baik, sudah tampil di depan. Sebelum presentasi dimulai ya, saya akan memberitahukan tata tertib untuk seminar hari ini. Yang pertama, Bapak Iwan Setiawan akan mempresentasikan material hari ini, lalu akan ada sesi tanya jawab setelah presentasi diikuti oleh conclusion. Baik, untuk Pak Iwan Setiawan, kami persilakan untuk mempresentasikan materialnya.
Oke, terima kasih Ibu Moderator. Please allow me to speak in bahasa, ladies and gentlemen, because everyone is better to understand in bahasa, I think. Ya. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Saya turun saja ya, saya di atas takut jatuh ya, mending di bawah saja lah ya. Supaya lebih terlihat ya, lebih enak jalan ke kiri dan ke kanan sambil ngecek teman-teman yang lagi tidur di belakang. Mudah-mudahan nggak ada yang tertidur di belakang ya, karena ini sebetulnya jam yang cukup krusial ya. Biasanya teman-teman semua mungkin jamnya tidur siang setelah duhur ya. Yang saya hormati juga di sini hadir perwakilan dari Bapak Ibu dosen. Ibu masih ada tempat di depan, silakan di depan. Pak Kartika ya, senior saya di sini ya. Terima kasih atas undangannya, terima kasih atas kehadiran rekan-rekan semua ya, adik-adik mahasiswa. Ini kebanyakan teman-teman angkatan berapa yang hadir nih? Dua-dua. Yang paling muda berapa? Angkatan berapa yang paling muda? Oh 24 ya. Berarti sudah dapat kuliah petrologi ya dari Pak Kartika dan Bapak Ibu dosen yang lainnya ya. Ini izin sebelum saya memperkenalkan atau membahas apa itu rare earth, saya ingin memperkenalkan BRIN ya. Sudah ada yang kenal BRIN? Sudah ada yang tahu BRIN? Coba saya pengen tahu yang dari paling belakang. Ada yang bisa menyebutkan atau menjelaskan apa itu BRIN? Yang paling belakang, boleh angkat tangan? Ayo, yang nanti ngacung bisa menjelaskan, angkat tangan dan bisa menjelaskan, nanti ada hadiah khusus dari Pak Kartika ya. Ayo, ada yang tahu BRIN apa? Tidak ada yang tahu BRIN? Jadi coba next slide biar gampang ya. Nah, BRIN itu adalah nama panjangnya adalah Badan Riset dan Inovasi Nasional. Kita terbentuk tahun 2021-2022 ya, menggabungkan 8 lembaga antariksa dan penerbangan, kemudian lembaga ilmu pengetahuan, BPPT, dan juga Batan dan Kemenristek. Tujuan kita digabungkan semua ini adalah untuk membuat kegiatan riset itu lebih bermanfaat ya, lebih efisien ya, dan memang berdampak istilahnya kalau sekarang ya. Jadi kita BRIN itu adalah lembaga satu-satunya yang menyelenggarakan riset dan inovasi. Selain perguruan tinggi, BRIN ini adalah satu-satunya di Indonesia yang mengerjakan atau memiliki tugas dan fungsi untuk melakukan riset dan inovasi. Penelitian, pengembangan, invensi, inovasi. Kalau sumber daya geologi ya khusus di bidang sumber daya geologi. Kita bertanggung jawab langsung ke Presiden ya. BRIN, kepala BRIN itu ada wakil kepala BRIN ya, ada inspektorat, ada sekretaris utama, kemudian ada deputi-deputi yang bertugas untuk melakukan pelayanan eksternal dan internal. Di sebelah kanan kita bisa lihat ada 12 organisasi riset dan pusat riset kami sumber daya geologi masuk ke dalam organisasi riset kebumian dan maritim. Ya. Nah, ini cukup jelas ya sampai sini ya. Coba next. Nah, kita banyak sekali program, bahkan untuk tahun ini kita kewalahan melakukan kegiatan-kegiatan riset. Karena terus terang kita butuh banyak periset muda sebetulnya. Ya, kita sekarang punya sekitar 67 periset ya. 30 diantaranya sudah senior, sudah sebagai peneliti utama. Ya. Kita kurang sekali peneliti-peneliti. Harapan saya nanti ke depan teman-teman semua, adik-adik semua bisa akan skema-skema BRIN ya, sehingga bisa melakukan penelitian terkait dengan ilmu kebumian. Sumber-sumber pendanaan kita itu ada dari RIM ya, Riset Inovasi Indonesia Maju, ada ekspedisi dan eksplorasi laut, ada ekspedisi geologi terestrial. Tahun ini kita melakukan di Jawa Tengah, fokusnya itu ya, semua bukti, semua potensi sumber daya geologi, dan juga risiko kebencanaan kita pelajari, fokusnya tahun ini Jawa Tengah. Kemudian ada juga research platform di bidang biologi, kemudian postdoctoral fellow, joint research, degree by research, visiting researcher, dan seterusnya ya. Kemudian next, Nah, untuk adik-adik semua ya, teman semua, saya harapkan benar-benar bisa memanfaatkan skema degree by research ya, yaitu pendanaan dari BRIN untuk melakukan kegiatan riset. Teman-teman semua melakukan pendaftaran secara online ya, memilih calon co-promotornya dari BRIN setelah diizinkan dari Bapak Ibu dosen dari kampus tentunya ya. Nah, nanti akan diberikan uang kuliah tetap, biaya penelitian, dan nanti dibundling ya langsung menjadi riset asisten. Kalau sudah menjadi riset asisten, teman-teman semua diupayakan bisa ada di Bandung atau di kota-kota di mana penelitinya hadir di situ secara permanen ya. Jadi selain selain untuk para mahasiswa juga kami mengundang Bapak Ibu dosen untuk berkolaborasi menjadi postdoc di BRIN ya. Ya, kita akan BRIN akan memberikan allowance ya yang cukup lah ya. Yang cukup juga akses ke semua di BRIN. Next. Ini saya cepat saja ya biar waktunya cepat untuk yang lain ya. Nah, ini teman-teman yang tertarik silakan masuk ke manajementalenta.brin.go.id, cari garis besar prosedur. Tentukan dulu topiknya apa dengan calon promotornya, kemudian pilih masuk kelompok riset yang mana, nanti akan saya jelaskan di BRIN atau di Pusat Riset Sumber Daya Geologi ada kelompok riset apa aja. Nanti teman-teman bisa bergabung di situ. Kemudian co-promotornya, kemudian daftar, upload, dan seterusnya. Jika rekan-rekan semua, adik-adik semua sudah memilih co-promotor dari Pusat Riset Sumber Daya Geologi misalnya, dan di-approve oleh co-promotor maupun oleh kepala pusatnya, insya Allah itu akan berjalan lancar. Ya. Sehingga teman-teman semua bisa masuk menjadi asisten peneliti sekaligus mahasiswa degree by research. Next. Nah, di bawah organisasi riset kebumian dan maritim, kita ada 6 pusat riset sekarang. Asalnya kita punya 10. Tapi sekarang yang berbau maritim, khususnya berbau hayati, dipindahkan ke organisasi riset hayati dan lingkungan. Ya. Nah, ini di bawah kami ini ada oceanologi, ya, oceanografi, laut dalam, limnologi dan sumber daya air, kebencanaan geologi, sumber daya geologi, kemudian iklim dan atmosfer. Rekan-rekan silahkan semua memilih topik apa yang paling sesuai di pusat-pusat riset ini. Ya. Mau masuk kebencanaan geologi, mau mempelajari tsunami silahkan. Kita punya banyak peneliti yang handal di bidang itu. Mau mempelajari tentang geofisika, mau mempelajari tentang longsoran, ya, dan seterusnya. Kita banyak tersedia peneliti ahli di sini. Oke, next. Nah, ini adalah ruang lingkup kegiatan riset kita. Dari mulai puncak gunung, ya, perbukitan, pantai, sampai ke laut yang terdalam. Gitu. Kita mempelajari juga bagaimana gunung-gunung api bawah laut itu terbentuk, bisa menghasilkan potensi bencana dan juga potensi sumber daya. Ya, ini sangat penting sekali untuk masa depan negara kita ya, terutama di Aceh ini ya, karena sedikit sekali lah ya dibandingkan dengan daerah-daerah lainnya publikasi terkait Aceh dari sisi bencana atau dari sisi geoscience. Next. Nah, ini adalah kepala OR dan ini adalah kepala-kepala PR yang ada di lingkungan ORKM ya. Nanti bisa langsung kontak langsung, jadi jangan sungkan ya, kalau di BRIN itu nggak boleh sungkan. Di BRIN itu egaliter gitu ya. Jadi tidak ada senior junior ya. Semua asal produktif itu bisa berprestasi ya, bisa berkarir lebih baik ya. Next. Nah, bagaimana peran BRIN dalam pengelolaan sumber daya geologi? Kita mulai fokus ke pusat riset kami sumber daya geologi. Next. Nah, pusat riset sumber daya geologi adalah pusat riset yang mempelajari semua material yang dihasilkan oleh proses-proses geologis, batuan, air, mineral, ya, panas bumi, minyak bumi. Ya. Kita pelajari semua di sini. Ada sumber daya geologi yang bisa diekstrak, kita akan pelajari, kita akan ekstrak, dan kita hasilkan material yang baru, yang lebih modern, bisa digunakan oleh perusahaan-perusahaan berbasis sumber daya geologi. Ya. yang tidak bisa diekstraksi kita lestarikan. Ya. Saya tahu di sini ada beberapa geopark nasional dan beberapa kandidat UNESCO Global Geopark. Nah, kita juga pelajari bagaimana pengelolaannya supaya lebih sustainable, memberikan manfaat lebih besar lagi kepada masyarakat. Ya. Kemudian ini adalah tujuannya, ya, sasaran dan seterusnya bisa dilihat semua, oleh rekan-rekan semua. Kita ada sekarang next coba. Ya, 8 kelompok riset, ya. Kebetulan di sini saya juga sebagai koordinator kelompok riset untuk geokimia, mineralogi dan geokronologi. Ya, ada kelompok riset lainnya yang koordinatori oleh Pak Dr. Rahmat. Mohon Pak Rahmat bisa berdiri. Barangkali nanti ada yang mau milih Pak Rahmat sebagai kopromotornya nanti di kemudian hari, ya. Beliau sebagai koordinator basin dinamika cukup, ya. Beliau secara ekspertis lebih banyak fokus di bidang mikropaleontologi. Kemudian di sini hadir juga Pak Ernowo, ya. Oh iya, saya juga terima kasih untuk teman-teman yang hadir di ruang Zoom, ya, secara online. Teman-teman dari Pusat Riset Sumber Daya Geologi juga hadir di ruang Zoom. Di antaranya Pak Ernowo juga hadir. Kemudian ada juga terkait dengan geothermal dan geomedical. Geothermal dan geomedical artinya kita mengaplikasikan geothermal untuk aspek kesehatan manusia dan kesehatan lingkungan. Kemudian ada juga terkait dengan marine geology. Ya, kita mempelajari dari mulai pesisir sampai laut dalam, dari mineral sampai ke yang lebih detail lagi, ya. Kemudian ada konsepsi geologi dan hilirisasi mineral oleh Pak Armin Tampu Bolon. Kemudian untuk rekayasa mineral atau rekayasa sumber daya geologi di sini ada Pak Solihin. Dan untuk pelestarian sumber daya geologi kita ada Pak Dr. Prahara Iqbal. Nah, kemudian dari kegiatan riset kami, ya, tentunya output yang diharapkan adalah publikasi, inovasi, invensi, rekomendasi dan kebijakan untuk Kementerian SDM, ya, karena yang paling dekat di sana, Kementerian Lingkungan Hidup, dan lain-lain. Ya. Next. Nah, kita mulai ke, ini masih kegiatan kita, ya. Kegiatan kita dari mulai Sumatera Utara, ya, sampai ke Papua. Aceh kita belum masuk. Terima kasih Pak Kartika, ini kesempatan yang sangat bagus sekali. Kita akan mulai di Aceh, ya. Kita akan lebih fokus melakukan riset di Aceh, ya, karena datanya masih kosong sekali nih. Jadi dengan kolega teman-teman kita dari Institut Geologi Geofisik, besar harapan kita untuk dapat mengeksplor lebih detail dari segi magmatik, ya, dan mineral deposit, juga aspek kebencanaan, ya, di Aceh. Next. Nah, ini kegiatan-kegiatan riset kita terkait dengan mineral deposit, ya. Perguruan-perguruan dari luar yang bekerja sama dengan Pusat Riset Sumber Daya Geologi. Nah, ini apa namanya, langsung loncat sini, ya. Lupa saya. Oke, kita mulai ini, ya, loncat ke rare earth dan juga critical elements, ya. Jadi di sini saya ingin mengenalkan tidak hanya rare earth, tapi juga critical elements. Sebetulnya rare earth itu adalah bagian dari critical elements juga. Apa itu yang dimaksud dengan critical elements? Yaitu adalah elements yang memang belum ada penggantinya, sangat dibutuhkan oleh industri-industri modern, ya, yang apabila terganggu kebutuhannya, pasokannya ke industri, ini akan mengganggu aktivitas ekonomi, pertahanan keamanan dan kesejahteraan sosial, ya. Jadi ini sangatlah penting. Nah, ini rare earth, ya. Teman-teman semua yang dimaksudkan rare earth itu hanya 17. Hanya 17 unsur. Tidak banyak, tidak lebih dan tidak kurang. 17 itu dari mulai lantanum sampai lutetium, ditambah scandium dan yttrium, ya. Mineral-mineral lainnya itu bukan rare earth elements, ya. Next. Nah, mineral-mineral ini adalah mineral yang dianggap kritis secara internasional, terutama di Amerika, yang berwarna merah ini diklasifikasikan sebagai mineral kritis, ya. Mineral kritis per definisi sudah disebutkan tadi, ya, dan karakternya tergantung kondisi geopolitik, tergantung dari sosial politik, ya, di masing-masing negara. Jadi yang dinyatakan critical elements di Indonesia tidak akan sama dengan yang ada di negara lainnya. Tergantung industri apa yang sedang berkembang dan membutuhkan material-material tersebut. Next. Oke, next. Nah, ini, ya, yang dimaksudkan dengan rare earth elements itu ternyata tidak benar-benar rare earth, tidak benar-benar langka sebetulnya. Kenapa dia dibilang langka? Karena dia cara keterdapatannya sangat sulit ditemukan di permukaan. Membutuhkan kondisi yang spesifik, lingkungan geologi tertentu ya, yang jarang ditemukan, jarang terkonsentrasi dalam jumlah yang ekonomis. Dan juga bagaimana memisahkan masing-masing unsurnya tidak bisa dilakukan dengan menggunakan teknologi yang sederhana, sangat kompleks. Semua memiliki valensi 3+, memisahkan unsur satu dengan unsur lainnya membutuhkan energi yang sangat besar. Ya. Jadi kita bisa lihat di sini yang berwarna merah itu rare earth dibandingkan dengan beberapa base metal dan juga precious metal itu ternyata jumlahnya masih lebih besar daripada mereka. Jadi artinya mineral ini atau unsur tanah jarang ini sebetulnya tidak langka, hanya kita yang belum banyak melakukan eksplorasi terkait dengan keterdapatan logam tanah jarang. Jadi ini tantangan untuk semua, terutama adik-adik yang masih relatif lebih muda ya, karena dari sisi umur kayaknya tidak terlalu jauh ya, masih 30-an lah ya, sama lah. Ya jadi ini secara teori ya, jadi artinya besar harapan kita untuk menemukan rare earth dimanapun kondisinya. Nanti saya akan jelaskan. Next. Nah ini menurut klasifikasi Vetrapi 2021 ya. Jadi yang dinyatakan kritikal untuk kebutuhan energi bersih itu ya. Untuk electric vehicles ya. Turbin angin ya. Magnet dan lain-lain. Ya terutama adalah neodymium, europium, terbium, dysprosium, yttrium dan erbium. Ya, yang lainnya sebetulnya tidak terlalu kritis. Karena apa? Karena tidak ada kebutuhan di industri dan harganya relatif lebih murah karena jumlahnya relatif abundant di permukaan, berlimpah di permukaan. Next. Nah ini definisi dari mineral kritis sudah disampaikan. Ini teman-teman dari Pusat Riset Sumber Daya Geologi yang juga memberikan masukan ya ke Kementerian SDM terkait dengan definisi dan unsur-unsur yang dinyatakan kritis dan strategis. Beberapa unsur kita lihat di sini, ada yang sudah memiliki cadangan, ya, ada yang sudah memiliki hanya bernilai sumber daya, ya, dan ada juga yang tidak memiliki informasi apapun. Ya, kalau kita lihat di sini dari unsur-unsur ini, ya, terutama yang tidak ada warnanya, boron, beryllium, bismut, karbon, kadmium, itu belum ada sumber dayanya. Belum ada cadangannya. Ya, jadi ini tantangan lagi nih kembali untuk teman-teman ya. Untuk non-conventional mineral deposit masih banyak yang bisa kita kerjakan. Tentunya ya selain base metal atau precious metal. Karena sebetulnya ini adalah mineral ikutan. Mineral penyerta dari mineral utama yang selama ini menjadi komoditas andalan. Seperti di emas, endapan emas, selain emas kita bisa temukan unsur-unsur seperti perak, ya, seperti titan, seperti aluminium dan seterusnya. Dari rare earth kita bisa temukan indium, ya, bisa kita temukan mineral-mineral atau unsur-unsur penting lainnya di sini. Jadi banyak kita kerjakan sama-sama ke depan. Next, oke, next. Nah ini yang tadi disebutkan mineral kritis. Jadi yang disebut dengan mineral kritis sudah disebutkan ya. Yang disebut kritis tadi sangat berperan terhadap aspek ekonomi ya, juga pertahanan keamanan ya. Yang mineral-mineral yang kritis dia pasti strategis, tapi yang strategis belum tentu dia kritis. Next, next. Nah ini aplikasi logam tanah jarang. Jadi teman-teman semua ya. Aplikasi logam tanah jarang itu sudah tidak bisa dilepaskan dengan kehidupan kita sehari-hari. Dari mulai kacamata yang kita pakai, ya, yang bagus-bagusnya itu pakai cerium, gitu ya. Ya, untuk laptop, untuk HP, untuk lampu, ya, untuk kulkas, gitu ya, untuk apapun lah ya. Kita butuhkan logam tanah jarang, ya, terutama untuk motor, magnet dan seterusnya. Ya. Dan tidak banyak sebetulnya logam tanah jarang ditambahkan ke dalam suatu komposisi material. Seperti di sini kita lihat untuk cellphone, rare earth itu dibutuhkan hanya sekitar 0,05 gram. Ya, bisa kita lihat kebutuhannya lain. Untuk misalnya turbin, untuk misalnya monitor, LCD monitor, untuk rare earth itu hanya 0,07 gram. Tapi dengan menambahkan sedikit saja logam tanah jarang, dan sedikit aja rare earth ditambahkan, itu akan meningkatkan efisiensi, akan meningkatkan kualitas dari produk yang dihasilkan. Ya. Kemudian begitu pula untuk kendaraan ya, bisa kita lihat sama-sama di sini. Next. Nah ini ya, seperti tadi ya, untuk AC, untuk bola lampu, alarm digital, AC dan seterusnya. Jadi benar-benar kita bertafakur lah istilahnya ya. Kita sebagai umat muslim gitu ya, berpikir bagaimana caranya kita bersyukur dengan cara belajar dan memanfaatkan sumber daya yang kita miliki. Next. Mohon maaf, lanjut ke geology of rare earth ya. Maaf loncat-loncat ini. Saya baru buat tadi malam ya. Next. Nah ini adalah skematik diagram terkait dengan logam tanah jarang yang saya padukan dengan emas ya, endapan emas. Endapan emas tidak akan saya bahas di sini, kita akan bahas logam tanah jarangnya saja. Intinya bahwa ya di setiap tectonic setting condition ya ada kemungkinan kita menemukan logam tanah jarang. Ya di daerah subduction di mana di sana terbentuk batuan-batuan orogenik ya, granit-granit atau granitoid yang tipe I misalnya, kita bisa temukan itu. Di belakang, di daerah-daerah belakang busur, di mana magma lingkungan geologinya rift ya, divergen, kita juga bisa temukan logam tanah jarang. Bagian-bagian belakang busur yang biasanya kita dapat ya. Di bagian depan kita sering temukan granit-granit yang tipe-tipe di bawah gitu ya. Di belakang kita bisa temukan atau di daerah rift alkaline granite yang juga rare earth yang dibeli placer atau follow placer kita biasa temukan byproduct di Bangka dan Belitung. Next. Nah, bagaimana logam tanah jarang itu bisa terbentuk pada granitoid? Mereka terbentuk karena proses diferensiasi magma, ya. Jadi magma berdiferensiasi sehingga logam tanah jarang yang sifatnya immobile, ya, yang sifatnya dia tidak mudah berikatan dengan mineral, terus berada dalam larutan. Ya, sedemikian mengikuti proses Bowern reaction series gitu ya. Sehingga mineral-mineral monasit, xenotim mengakumulasi logam-logam tanah jarang pada produk akhir magmatik. Ya. Kemudian ada juga logam tanah jarang yang terbentuk dari proses silapukan, di mana ditransport pada lapisan soil tertentu ya, di mana logam-logam tersebut tertangkap oleh mineral lempung dan seterusnya. Dan di bawah adalah logam-logam atau unsur mineral-mineral yang biasa membawa logam tanah jarang yang ada di Indonesia. Sebetulnya masih banyak lagi ya, tapi ini yang paling dikenal adalah mineral-mineral yang kita bisa lihat di depan ini. Next. Nah, ini beberapa klasifikasi dari logam tanah jarang. Yang paling kenal ini terutama di Bayan Obo ya. Itu adalah kombinasi dari carbonatite dan juga tipe hidrotermal. Kemudian ada juga alkalin ya. Ada juga sedimentary dan secondary ya. Yang paling ramai, yang paling potensial di Indonesia adalah terutama yang alkaline dan juga yang secondary. Next. Yang paling visible, yang berdasarkan data-data yang kita punya, mohon maaf izin koreksi ya, tadi yang paling visible untuk diolah adalah memang yang monazite atau placer RI deposit. Di mana monasit hasil pelapukan masa lampau terakumulasi di daerah Bangka dan Belitung. Ya. Itu adalah byproduct dari pengolahan dan juga serawatnya erosi dari batuan-batuan granit tipe S. Ya. Nah, secara primer di Indonesia kita bisa berharap ke batuan-batuan alkalin, ya, batuan-batuan potasik, kemudian di metamorfik. Ya. Tapi yang paling potensial untuk yang primer terutama adalah batuan-batuan alkalin dan yang potasik sodik lava. Kemudian yang di secondary yang sudah teridentifikasi sejauh ini terutama adalah di North Sumatera. Di Sibolga kita bisa temukan pengkayaan dari logam tanah jarang, bukan. Ya. terlalu besar, tapi berdasarkan data-data dari lab analisisnya menunjuk atau cenderung ke arah ion adsorption time. Ya, yang alternatifnya kita bisa temukan juga logam tanah jarang di dasar samudra. Ya. Banyak juga di situ lumpur-lumpur, ya, lumpur-lumpur yang kaya akan rare earth yttrium dan juga nodul mangan yang berhubungan dengan polimetalik. Kita bisa berharap di sana. Nah, ini tantangan masa depan untuk adik-adik semua, teman-teman yang masih muda terutama ya, yang masih mempunyai nafas yang panjang, yang adrenalinnya sangat besar ya. Ini saya sangat berharap ke depan alumni atau mahasiswa dari sini ada yang menjadi ahli di bidang ini ya, di bidang rare earth atau di mineral deposit. Next. Nah, ini adalah major mine REE yang sedang berjalan atau sudah berkembang yang mengandalkan mineral basnasite, monazite, sonotime dan seterusnya ya. Cina punya semuanya ya. Cina punya semuanya, makanya negara Cina lebih maju. So, Prof. Linwei, so China has many varieties of rare earth elements, rare earth bearing minerals. That's why you are more developed, more powerful right now. Ya, jadi ini teman-teman kita semua punya potensi ini, ya. Tapi kita tidak atau belum melakukan eksplorasi secara mendetail. Kita punya, tapi belum tahu seberapa yang bisa kita olah secara ekonomis berdasarkan teknologi yang sekarang kita punya. Next, nah, ini adalah mineral-mineral lain yang berhubungan dengan logam tanah jarang yang sebetulnya bisa kita usahakan. Tapi pemerintah dan negara ini lebih fokus ke mineral-mineral monasit dan sanotip. Selain mengandung logam tanah jarang, dia juga mengandung unsur radioaktif. BRIN dalam hal ini juga mengembangkan ekstraksi, tidak hanya logam tanah jarang, tapi juga unsur-unsur radioaktif. Ya, dan ini juga kembali tantangan, mungkin ada Bapak Ibu dosen yang lebih advance. Jika ingin mempelajari atau memperdalam terkait dengan pengolahan, ekstraksi, terkait juga dengan lingkungan, bisa bergabung di teman-teman kelompok riset yang ada di BRIN, di Pusat Riset Sumber Daya Geologi. Next. Nah, ini adalah proyek-proyek logam tanah jarang, berdasarkan tipe-tipe endapannya, sudah sangat banyak dan berkembang di luar negeri ya. Next. Nah, ini terutama dari carbonatite itu 62%. Ya. Jadi 62% logam tanah jarang disuplai atau dihasilkan oleh batuan yang dinamakan karbonatite. Kita sementara ini belum teridentifikasi. Ya. Ada yang sudah berspekulasi terdapat karbonatite, tapi belum ada informasi yang detail atau ilmiah. Ya. Sedang di Indonesia terutama yang tadi saya sebutkan, yang alkaline igneous rocks. Next. Ya, ini kita di Asia Tenggara juga Myanmar, Vietnam, potensi logam tanah jarang yang cukup besar gitu ya. Ya, cukup besar potensinya ya. Indonesia di sini kita lihat sama-sama belum ada ya. Definisikan apakah di Indonesia ada logam tanah jarang atau tidak. Next. Nah, paling tidak sejak tahun 2019 USGS mengidentifikasi atau kita telah teridentifikasi bahwa selain indikasi kita memiliki potensi yang juga cukup baik terkait dengan logam tanah jarang, terutama di wilayah Sumatera. Ya. Jadi kita dikenal memiliki logam tanah jarang sejak tahun 2019. Padahal kegiatan eksplorasi kita sudah lebih awal daripada negara-negara di Asia Tenggara lainnya. Ya. Kenapa ini RE dulu tidak berkembang di Indonesia? Karena ada regulasi yang menyatakan bahwa semua mineral yang berkaitan dengan logam tanah jarang hanya dikelola atau boleh dikelola oleh Badan Tenaga Atom Nasional. Karena mengandung unsur radioaktif. Tapi sekarang itu udah ada perubahan sehingga mineral monazite itu sudah disamakan dengan mineral industri lainnya. Dikeluarkan dari kelompok mineral yang mengandung radioaktif sehingga bisa diusahakan. Tapi untuk yang ada hambatan sehingga industrialisasi atau pemanfaatan atau lelang IUP terkait logam tanah jarang masih berkendala ya. Next. Nah, bagaimana dengan di Indonesia? Saya akan sampaikan beberapa data-data awal ya yang mudah-mudahan bisa menginspirasi teman-teman semua untuk mempelajari lebih detail terkait dengan logam tanah jarang. Next. Tadi udah disebutkan ya, terutama yang tipe-tipe alkali ya, tipe-tipe ion adsorpsi itu ada potensi yang paling besar yang ada di Indonesia. Next. Nah ini kenapa bisa ada potensi itu ya? Kita kembali lagi ke setting geologi yang kita punya. Ya. Setting geologi kita punya, kita bersyukur berada di kawasan yang sangat aktif, menjadi laboratorium geologi yang sangat penting, di mana proses-proses abduksi yang terjadi menghasilkan selain proses kebencanaan atau resiko kebencanaan juga menghasilkan sumber daya geologi. Coba next. Ya, kita punya 128 cekungan yang terbentuk akibat interaksi lempeng ini. Ya. Kemudian kita memiliki 331 geothermal potensial. Ya. Kita salah satu kawasan yang memiliki potensi geothermal yang sangat besar dan kurang dari 10%-nya sudah dioptimalkan. Ini juga challenge untuk adik-adik semua ya, untuk melihat lebih luas lagi, membuka wawasannya bahwa negara kita ini kaya dan kita belum melakukan apa-apa. Tidak banyak yang sudah kita lakukan untuk potensi-potensi yang kita miliki. Ya. Selain itu kita memiliki 421 cekungan air tanah, 15 busur magmatik dan seterusnya. Ya. Untuk erupsi vulkanik dan lain-lain tentunya menjadi resiko yang juga harus kita waspadai ke depan. Next. Nah ini ya kaitannya dengan Sumatera. Ya. Sumatera itu adalah extension dari Tin Belt, ya, Southeast Asian Tin Belt. Tapi studi granitoid di mainlandnya itu belum lengkap atau bahkan tercecer, ya, tidak dilakukan. Ya, padahal untuk mengidentifikasi atau apabila kita mengeran dari granit ini, maka untuk menemukan potensi logam itu lebih mudah atau lebih terarah. Ya. Nah kita lihat bahwa granitoid yang tersebar di kawasan Southeast Asian Tin Belt itu ujung Sumatera. Tidak ada garis yang meneruskan bagaimana kemenerusannya di bagian utama Pulau Sumatera. Next. Nah kita lihat bahwa kalau secara umum ya, secara umum dari barat ke timur, dari Eastern Province ya, kemudian ke Main Range dan ke Western Province, itu adalah variasi dari granitoid yang tidak sesederhana yang kita lihat di lapangan. Ya kalau disebutkan bahwa kalau di Eastern Granite itu adalah tipe I ya, kemudian di Main Range itu tipe S, di bagian barat adalah kombinasi tipe I dan tipe S. Jadi keterdapatan granit itu tidak sesederhana yang kita bayangkan. Ya, perlu pendekatan yang lebih lengkap. Selain riset-riset dasar, kita perlu melakukan riset-riset yang advance. Bagaimana mengidentifikasi granit dari sumbernya, berdasarkan sumbernya. Ya. Next. Ini sebaran logam yang ada di Indonesia. Di Sumatera kita bisa lihat ya sudah terkenal sejak dulu banyak potensi atau cadangan polimetalik logam dasar ya, dan juga potensi rare earth sebetulnya yang belum kita detilkan. Harapan saya ke depan ada 1-2 mahasiswa ya untuk semester ini atau semester depan bisa melakukan skripsi atau penelitian bareng gitu ya. Ibu bu dosen mau kalau ada mahasiswanya mau belajar granit, rare earth gitu ya, silakan menghubungi kami ya lewat email atau lewat Pagartika bisa ya. 2-3 mahasiswa belajar logam tanah jarang, ada yang mau belajar basin evolution, basin dynamic, silakan hubungin. Terdekat saya harapkan ada 2-3 mahasiswa mau belajar hard rock ya, igneous rock, granitoid kaitannya dengan mineralisasi ya. Untuk tentunya kemakmuran kita semua ya. Next. Nah ini adalah data-data prospektif logam tanah jarang yang ada di Indonesia. Sebetulnya kita sudah mengerjakan sejak tahun 1989. Ya, negara-negara Asia Tenggara lainnya belum melakukan itu, kita sudah melakukan. Tapi kenyataannya sekarang kita masih tertinggal Karena kita memang kekurangan SDM, kekurangan geologis yang benar-benar mau bekerja di bidang ini. Ya, sekali lagi saya mohon dari adik-adik mahasiswa ya bisa ada yang terlibat di kegiatan ini. Ya. Oke, next. Nah, ini beberapa kegiatan yang sudah kita lakukan selain di Sumatera, kita juga mengerjakan riset di Jawa, itu di Muria. Di situ ada batuan alkalin dan juga batuan sosonitik yang menurut hipotesa secara konseptual berhubungan dengan potensi logam tanah jarang. Kemudian di Ambon ya dan juga di Papua, di mana di sana sebaran granit tipe S maupun tipe I tersebar sangat luas dan berlimpah. Next. Nah, selain tadi granit yang dihasilkan rare earth atau rare earth bearing mineral yang dihasilkan dari granit, residual produk ya dari granitoid, kita juga memiliki potensi logam tanah jarang terutama dari tanah lapukan. Kenapa kita memiliki potensi granit rare earth di tanah lapukan? Karena menurut peta ini ya, kita bisa lihat bahwa wilayah Indonesia sama seperti wilayah lainnya dari negara-negara yang menghasilkan rare earth itu berwarna merah. Artinya warna merah di sini adalah berada pada lingkungan yang tropical, ya, tropical climate. Tapi sayangnya untuk Indonesia dia lebih hangat, ya, lebih hangat dan curah hujannya tinggi. Sementara di wilayah lainnya yang berwarna merah ini seperti Southern China ini, ya, rare earth-nya terpreservasi dengan baik pada soil. Ya, sementara di Indonesia si logam tanah jarang, ion-ion yang terjebak atau tersimpan dalam lempung, dia tercuci, leach out, ya, oleh hujan, ya. Kemudian dia terbawa ke suatu daerah aliran sungai. Ya, jadi tapi secara umum potensi logam tanah jarang tipe ion adsorpsi ini ada di Indonesia. Dan kita belum temukan daerah mana yang benar-benar kita bisa manfaatkan secara ekonomis. Gitu. Next. Nah, ini konsepnya ya. Jadi kalau misalnya ada satu batuan granit atau granitoid, kalau dia lapuk, gitu kan? Kalau dia lapuk, membentuk residual deposit. Mineral-mineral pembawa logam tanah jarangnya pecah dari batuan, kemudian terkumpul. Rare earth-nya ada di dalam kristal-kristal itu. Tapi kalau di tanah lapukan, ya tanah lapukan, kristalnya hancur karena air meteorik, dibawa oleh air meteorik, dibawa oleh organik material, dibawa oleh besi, ion-ion besi, dan seterusnya, tertransport dan nempel karena lempung itu memiliki elektropositif yang tinggi, ya, besar, sementara lempung memiliki elektronegativitas yang tinggi, kemudian dia saling menangkap gitu ya. Next. Nah, ini beberapa contoh tipe ion adsorpsi yang bisa diidentifikasi di daerah Sibolga. Next. Kandungan logam tanah jarang itu bisa lebih besar dari 2000 ppm. Ya, masih kecil dibandingkan dengan negara-negara penghasil logam tanah jarang lainnya di kawasan Asia Tenggara. Jadi konsepnya atau modelnya bahwa ion logam tanah jarang dari granit di permukaan granit itu mengalami oksidasi, seriumnya berikatan dengan oksigen menghasilkan Ce2O2, cerianide. Ya. Kemudian ion-ion lainnya mobile bersama dengan air meteorik dan pembawa lainnya, carrier yang lainnya, terutama iron, lead, ya, kemudian organik material tertransport dan tadi tertangkap oleh dalam mineral lempung. Ya, kalau ketika kita mendapatkan sampel batuan, kita analisis whole rocknya, kemudian kita menemukan volasesium atau serium yang positif, ya, relatif positif, itu artinya dia mengalami pengkayaan di permukaan. Ketika dia mengalami pengkayaan di permukaan, kita bisa berharap ion-ion lainnya akan mobile, tertransport ke bawah, ke satu horizon, biasanya ada di horizon B maupun di horizon C, ya. Dan dia terakumulasi. Kita namakan itu adalah accumulation zone. Di atas ada oxidation zone, di bawah ada accumulation zone. Ini sederhananya seperti itu ya. Next. Nah, ini adalah tahapan-tahapan untuk memastikan apakah tipe itu adalah tipe adsorpsi atau bukan. Ketika ion-ion itu terabsorpsi oleh lempung, ketika ion-ion dari rare earth elements itu terekstrak lebih banyak oleh larutan nomor 2, gitu, ya, exchangeable neutral salt, ya, nomor 2 ini. Artinya larutan ini atau reagen ini telah berhasil mengekstrak ion-ion logam tanah jarang dari lempung. Jika ini 50 jumlahnya 50% atau lebih besar sama dengan 50%, maka ini adalah tipe ion adsorpsi. Ya, seperti itu. Jadi tahapan-tahapannya tidak mudah. Ini mengerjakan ini 3 bulan sendiri ini. Karena ada 8 sampel, 8 tahapan yang harus kita ikuti secara konsisten. Dari mulai sampel kita hancurkan, kita sampai punya powder sekitar 0 atau setengah gram, dicampur dengan 20 ml reagen, ya, mengikuti tahapan-tahapan seperti ini. Kemudian kita pregnant solutionnya kita ambil, kita pakai lagi dengan reagen yang lain dan seterusnya. Jadi banyak sekali tahapan yang harus kita lakukan sehingga kita bisa membuat suatu tipe dari endapan logam tanah jarang. Next. Nah, ini di Sumatera, ya, ini masih data yang harus kita konfirmasi. Ini adalah data-data yang dihasilkan oleh teman-teman dari Badan Geologi. Distribusi dari logam tanah jarang di Sumatera dari mulai di Kuliah, ya, Permonangan, Sibolga, kemudian Bangkinang, Pegunungan 30, Timah, dan seterusnya. Ya, ini kebetulan untuk daerah-daerah di Kepulauan Riau saya masih punya akses yang terbatas dan juga untuk Aceh, ya. Mudah-mudahan semua granitoid di Aceh bisa kita identifikasi melalui kegiatan yang akan kita lakukan dalam waktu dekat ini. Next. Nah, ini di Bangka, ya. Jadi selain daripada batuan sumbernya yang granitoid tadi, terutama granit tipe S, juga banyak juga granit-granit atau rare earth yang tipe-tipe residual, ya. Karena ini sangat umum sekali dari sisa pengolahan timah di Bangka. Next. Ini yang di Belitung juga sama, ya. Ekstensi dari Southeastern Belt in Asia, Southeast Asia. Ini juga masih perlu kita detilkan karena granit-granit yang tipe S juga dia mix dengan tipe I. Kita harapkan kita masih memiliki potensi logam lain selain rare earth yaitu tungsten dan MO di sini. Next. Ini ada data juga dari Badan Geologi, masih harus kita konfirmasi dan masih kita harus detilkan berdasarkan konsep yang baru, ya. Next. Nah, intinya bahwa Indonesia memiliki potensi untuk logam tanah jarang, ya, dari granitoid tipe primer dan juga tipe sekunder itu tipe ion adsorpsi. Kita perlu bekerja sama, ya. Logam tanah jarang ini adalah sangat penting, krusial untuk kebutuhan industri modern. Tapi kita kenyataannya belum banyak melakukan kegiatan riset. Salah satu masalahnya adalah kita tidak berkolaborasi. Harapan saya kita semua bisa berkolaborasi, BRIN, perguruan tinggi, industri bekerja sama-sama, fokus, ya, sehingga potensi logam tanah jarang ini atau mineral deposit ini bisa kita temukan lebih cepat, tepat, dan lebih murah. Terima kasih Bapak Ibu semua. Mudah-mudahan ada manfaatnya. Saya kembalikan ke Ibu Moderator. Assalamualaikum warahmatullahi wabarakatuh.
Baik, Pak Iwan Setiawan, pembahasannya sangat menarik, ya, tentang REE, ya. Yang saya poin untuk REE saat ini dari pembicaraan Pak Iwan tadi adalah bahwa untuk Sumatera, terutama Aceh sendiri masih sangat minim, ya, untuk analisis REE. Makanya saya pernah lihat, Pak, memang poster untuk mengajak mahasiswa ikut riset dengan BRIN saat itu. Mungkin belum, adik-adik ada yang ikut di sini riset bareng BRIN? Belum, ya. Mungkin next akan lebih dipromosikan lagi, ya, Pak, agar ada salah satu dari geologis di sini, geologis muda yang ikut riset bareng BRIN selanjutnya, gitu, ya. Baik, setelah pemaparan tadi kita buka sesi pertanyaan untuk 2 orang penanya, baik secara offline di ruangan kerukun ini maupun secara online melalui Zoom. Baik, yang melalui Zoom boleh diketik. Oke, sepertinya belum ada. Oh, sudah ada. Baik, kita dari yang di ruangan offline dulu, ya, silakan untuk panitia. Sepertinya yang di belakang. Silakan sebutkan nama dan prodi dari prodi mana.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Izin Pak, terima kasih atas kesempatannya. Terima kasih juga atas ilmu dan knowledge yang sangat meaningful ini Pak. Sebelumnya izinkan saya mengenalkan diri dulu. Nama saya Amran Sari. Saya dari Prodi Teknik Pertambangan Universitas Kuliah. Saya dari angkatan 2022. Tadi Bapak sudah ngebahas seputar ada satu daerah di Sumatera Utara, khususnya Sibolga, dia yang berpotensi memiliki kandungan unsur tanah jarangnya. Pertanyaan saya ialah Pak, apakah sudah ada penelitian seputar daerah mana di Sumatera, kecuali daerah Sibolga tersebut, yang berpotensi adanya unsur tanah jarang atau RE? Terkhususnya itu indikasinya berdasarkan data geologi. Terus itu apakah kebijakan eksplorasi mineral tersebut apakah kebijakannya tuh sudah dapat dimanfaatkan atau belum, Pak? Seperti itu. Terima kasih.
Baik, mana Pak Iwan langsung dijawab? Baik.
Langsung jawab aja, mumpung belum lupa ya. Jadi untuk yang Sibolga, dia memiliki potensi logam tanah jarang, sudah banyak hasil penelitian di sana. Yang terbaru juga ada ya, mahasiswa dari Pajajaran juga publish terkait dengan mineralisasi logam tanah jarang di Sibolga. Kemudian yang di mana? Yang terkait dengan sebaran lainnya di Sumatera. Di Sumatera tentu banyak sekali ya. Dari mulai Aceh tadi ya, kita lihat di slide juga ditunjukkan. Dari mulai si Kuliah ya, tidak hanya si Kuliah sebetulnya. Tadi saya sampaikan juga pada saat presentasi bahwa rare earth itu tidak langka. Rare earth itu di batuan apapun ada, tapi jumlahnya sangat kecil. Kita butuh yang konsentrasi dan mudah didapatkan. Butuh lingkungan geologi yang tertentu sehingga dia bisa terakumulasi gitu ya. Jadi dari mulai Aceh itu banyak sekali granitoid. Kita tahunya si Kuliah batolit aja, padahal banyak ya, tangse gitu. Granitoid itu tidak hanya granit. Granitoid itu adalah kumpulan dari felsic intrusif. Jadi granit, granodiorit, ya diorit, ya, cyanit, monzonit, itu adalah granitoid. Jadi banyak sekali potensi di Aceh yang kita bisa detilkan. Siapa yang akan mengerjakan? Ya, tentunya adik-adik semua gitu. Saya untuk perjalanan ke Aceh butuh biaya besar gitu ya. Makanya teman-teman yang dari Aceh nanti coba mahasiswanya kalau bisa dipetakan ya. Dipetakan kembali distribusi dari granitoidnya gitu ya. Dianalisis sederhananya gitu ya. Dan kita akan bantu analisis yang advance-nya gitu ya. Untuk benar-benar mengetahui bagaimana potensi yang ada di Aceh. Ya. Selain di Sibolga, sebetulnya ada juga di daerah Parmonangan ya di utara Sibolga. Parmonangan, Muara Sipongi, Penyabungan, Pegunungan 30 dan itu banyak sekali. Tapi sejauh ini kita hanya mampu mengidentifikasi tipenya saja. Kalau hanya mengidentifikasi tipenya saja itu baru permulaan. Ya, jadi kita benar-benar harus melakukan analisis atau riset yang lebih sistematik. Ya. Nanti kalau ada kesempatan teman-teman yang di sini bisa ikut ke lapangan gitu ya. 1 hari, 2 hari ikut ke lapangan untuk benar-benar merasakan lah. Ya, merasakan mungkin Pak Kartika ya bisa membawa 1 atau 2 mahasiswa ikut ke lapangan benar-benar memahami bagaimana kegiatan penelitian ini dilakukan, terutama terkait dengan granitoid. Itu mungkin sementara bisa saya sampaikan.
Tadi ada satu lagi ya pertanyaannya tentang kebijakan REE Pak.
Nah kebijakan RE tadi juga sudah disampaikan bahwa sekarang ini monasit sudah dikeluarkan dari mineral pembawa radioaktif sehingga bisa diusahakan oleh industri, oleh swasta. Tapi lelang tahun 2023 atau 2024 setahu saya belum berjalan dengan lancar. Lokasi yang di Mamuju, ya, lokasi yang di Keposang itu belum berhasil mendapatkan investor karena dianggap, saya tidak terlalu detail ya permasalahannya apa, ada faktor teknis yang belum bisa diterima oleh industri. Ya. Dan salah satu juga masalah yang kita miliki adalah banyak teknologi yang dikembangkan atau teknologi yang diimport ternyata belum sesuai dengan karakteristik sumber daya yang kita miliki. Makanya hulu hilir harus benar-benar kita kuasai. Hulu hilir harus kita kerjakan sama-sama. Sehingga benar-benar teknologi yang kita kembangkan, yang kita gunakan itu benar-benar sesuai dengan berapa jumlahnya, ya, bagaimana kualitasnya, sehingga benar-benar bisa digunakan, dimanfaatkan, dieksploitasi oleh teman-teman di hilirnya gitu ya. Itu mungkin.
Baik, bagaimana pertanyaannya sudah cukup memuaskan? Oke, baik. Selanjutnya kita, wah banyak sekali Pak sebenarnya pertanyaan ini ya Pak ya, tapi karena hanya 2 kesempatan ya yang kita terima secara offline aja dulu ya teman-teman. Baik, satu lagi tadi ada yang di bagian depan. Baik, silakan panitia sebutkan nama dan prodinya ya.
Assalamualaikum warahmatullahi wabarakatuh. Selamat siang Bapak, sudah memaparkan materi yang mungkin cukup baik lah. Pertanyaan saya, melihat tingginya ketergantungan industri ini terhadap logam tanah jarang seperti Nd, Pr, dan Dy dalam produksi permanen magnet performa tinggi. Apakah pengembangan material magnet berbasis REE seperti Fe, Ni, dan Co atau Hauser alloy benar-benar dapat menjadi solusi strategis jangka panjang? Sejauh mana inovasi material ini mampu menandingi stabilitas, densitas energi magnetik, dan efisiensi magnet berbasis NdFeB tanpa mengorbankan aspek perekonomian dan keberlanjutan produksi? Dan sebelumnya tadi saya dari Prodi Teknik Pertambangan Angkatan 2023. Terima kasih.
Baik Pak, silakan dijawab.
Pertanyaannya cukup berat ini. Cukup berat ini, tapi bagus pertanyaannya ya. Bagaimana neodymium dan lain-lainnya benar-benar bisa berkontribusi untuk pemanfaatan magnet ya. Jadi itu cita-citanya begitu ya, cita-citanya bahwa kita bisa memanfaatkan neodymium, praseodymium, dysprosium untuk magnet permanen dan lain-lain gitu ya. Nah kendalanya bahwa di Indonesia yang menjadi andalan adalah monasit dan xenotim. Monasit itu membawa light rare earth elements. Monasit itu membawa lantanum, cerium, praseodymium, gitu ya, europium, gitu. Tidak membawa kebanyakan mineral yang kita butuhkan untuk magnet. Yang light rare earth elements itu lebih banyak digunakan untuk sebagai katalis, ya, tidak sebagai untuk motor atau untuk magnet. Jadi masih belum meyakinkan ya untuk Indonesia bisa mengembangkan ke arah motor atau ke arah magnet atau permanen magnet. Karena yang diandalkan adalah monasit. Sementara xenotim itu hanya membawa unsur namanya yttrium. Ya. Jadi ke depan kita masih harus mencari unsur-unsur atau mineral-mineral pembawa heavy rare earth elements. Heavy rare earth elements itu biasanya ada di batuan-batuan yang lebih ke banyak mengandung mineral-mineral seperti titanit gitu ya. Kalau alanit masih cerium, tapi masih banyak lah ya yang belum kita temukan. Kalau hanya masih mengandalkan monasit dan xenotim, maka arah ke sana masih cukup panjang gitu ya. Tapi kalau untuk pemanfaatan light rare earth itu kita ada harapan karena sumbernya itu ada. Mungkin itu seperti itu ya.
Bagaimana pertanyaannya, cukup menjawab? Baik Pak, sudah menjawab.
Ini izin ya, untuk teman-teman di geologinya ada pertanyaan nggak? Tadi dua-duanya tambang ya?
Iya benar Pak, yang geologi
teman-teman geologinya mana ini?
Masih.
Nah,
geologi ini Pak ada dari Zoom ya Pak, bisa?
Boleh
Satu lagi ya teman-teman ya. Baik, pertanyaannya Pak saya bacakan. Salam, perkenalkan saya Dina ya Pak, dosen teknik geologi, bidang petrologi dan geokimia hard rock. Susah di sini, saya baca seperti ini. Saat ini tertarik melakukan penelitian tentang REE dan memulai penelitian pada genesis batuan granit intrusi sama 2. Dari geokimia terlihat granit tipe I, sehingga jika dibandingkan dengan REE di Sibolga dan Sumatera bagian selatan, masih belum terkayakan secara signifikan. Apakah mungkin untuk daerah ARK menghasilkan granitoid tipe A dan S, atau memungkinkan granit tipe I memiliki pengkayaan yang signifikan seperti tipe A dan tipe S?
Oke, baik, terima kasih pertanyaannya ya. Jadi intinya bahwa untuk tipe residual monocyte atau REE placer deposit itu sumbernya adalah tipe S. Ya, di mana granit-granit tipe S banyak mengandung monasit dan xenotim. Untuk tipe-tipe I atau tipe A itu lebih ke arah heavy rare earth, ya heavy rare earth dan ion adsorpsi. Karena di sana tipe I itu karena magmanya atau granitoidnya teroksidasi dari awal, pembentukannya banyak mengandung mineral-mineral pembawa rare earth juga, gitu kan. Baik light rare earth dan heavy rare earth. Kalau kita lihat polanya tipe I dan tipe A itu dia relatively flat, hanya di europiumnya aja yang depleted, heavily depleted ya, sangat curam deplesinya kan. Dari mulai light rare earth relatif datar, turun di europium dan dia relatif naik. Jadi ada potensi untuk heavy rare earth di sana, gitu kan. Nah justru kalau untuk mencari yang ion adsorpsi seperti yang di Sibolga itu bisa mengalami pengkayaan. Jadi yang kita harapkan itu pengkayaan yang tadi yang ion adsorpsi. Jadi ketika sumber dari granit itu membawa sejumlah logam tanah jarang, dia banyak tertransport dan tertangkap di lapisan lempung tadi. Nah terkayakan di sana. Jadi kalau untuk mau eksplorasi placer deposit itu di tipe S, untuk mencari tipe ion adsorpsi potensi yang terbesar adalah di tipe I. Karena di sana punya alanit dan tetanit yang memiliki karakter lebih mudah hancur secara fisik dan secara kimia. Ketika mineral pembawa logam tanah jarangnya lebih mudah hancur, maka dia lebih mudah tertransport. Sedangkan monasit dan xenotim dia lebih susah terlapukan, hancur. Sehingga REE tetap berada di dalam kristal itu. Ya, mungkin bisa ditangkap ya oleh teman-teman yang ada di Zoom ya.
Ya, mudah-mudahan granit sama dua berada di Aceh, Tapak Tuan, katanya ya Pak. Bagaimana Bu Dina? Ada yang perlu ditambahkan? Mudah-mudahan cukup menjelaskan ya dari penjelasan Pak Iwan tadi. Karena waktu kita sangat terbatas hari ini ya teman-teman. Kita cukupkan untuk 3 pertanyaan ya untuk sesi tentang REE di Pulau Sumatera terutama ya. Baik, sebelumnya kita ucapkan terima kasih dan beri tepuk tangan untuk Pak Iwan. Baik, terima kasih Pak Iwan. Baik teman-teman, karena dari panitia ternyata ada coffee break sebentar di bagian belakang. Selama 5 menit untuk teman-teman dipersilakan untuk menikmati coffee break di belakangnya. Terima kasih. We have some coffee breaks in the back. Okay. Baik, teman-teman, selagi menikmati coffee break, ya, kita bisa kembali ke sesi selanjutnya. Apa? Okay, ladies and gentlemen, mungkin our coffee break bisa dinikmati di seat masing-masing ya. Okay.
Okay, no problem.
Okay. Attention, please. Our second session will continue. Our second session will talk about tectonic framework of the Sumatra response to oblique plate convergence. We would like to invite Professor Wei Lin to the stage. Please, sir. I will introduce our second speaker, Professor Wei Lin. Okay, we can see first. I will read first the curriculum vitae of Professor Wei Lin. Currently, as a professor at the Institute of Geology and Geophysics, Chinese Academy of Sciences, since 2008, he has received his bachelor degree at Department of Applied of the Geophysics, Changchun University of Earth Sciences, then taken his master degree at the Department of Earth Science, Nanjing University here. You can zoom in again. Yeah. And then his work is his doctoral degree at Department of Earth Science, Orleans University. His work experiences for doctoral and professor at Institute of Geology and Geophysics, Chinese Academy of Sciences, and research fellow in Orleans and Montpellier University. He also was awarded and honored for French Minister des Affaires. I'm sorry, I can't speak French, but it was awarded by French China Scientific Corporation, AFCRST, in 2002, and then Outstanding Science and Technology Achievement Prize of the Chinese Academy of Sciences, 2014. He also has supported projects that related to tectonics and sedimentary basins. Okay. Since 2005 till 2016, such as NSFC project focusing on structural geology with funding 2 million yuan in 2013 until 2016. He has already actively published several publications for international journals such as Journal of Geophysical Research, Solid Earth in 2018 with the team. Okay, without further ado, welcome the speaker, Professor Waylin, to deliver his presentation. Professor Waylin, the time is yours.
Okay, thank you. Thank you very much, the President, to introduce myself. Sorry, what I prepared at the beginning, I think it is, yes, okay, I will see Selamat Siang to all the people. It's my pleasure to come here for of university present the work of the last year, concentrated your hometown, your homeland, and like the president have introduced by myself, I'm quite popular in China. If you know, my undergraduate is from not so common as college or institute of Changchun. Is not very famous. Like now, I working in this institute, and at the beginning for the undergraduate study is geophysics. So you will find I'm working at the structural geology. What I have learned, the method of the working, let me become a professor, is after my 27 years old. In my 27 years old, I go to France to learn the French, to learn the method of how to analyze the structural geology. According to my colleague, a French colleague said, okay, this guy reborn in France. So I would like give you great encouragement. Even I can work beginning and reborn from the 27 years old. For you, you will learn very well the structural geology, the tectonics from now. So I'm quite sorry. I speak English with the French accent. I hope you can understanding. And of course, for the presentation, I prefer use the Chinese, but because it is much easier for me, because the English is working language, we can use it everywhere. Okay, I speak English with my French accent. I'm quite sorry about that. And here is the topic. So I speak as slowly as I can. If you have any question, I can stop, no problem. And the tectonic framework of the Sumatra, your homeland. Next, please. And here I would like to grateful Professor Ivan. Is he let me have a chance to working here. And here is a group of photo for the Chinese and the brand work together on the topic of the tectonic framework of the Sumatra. Next, please. And here I would like to express my sincere gratitude for Ivan, Maruf, and Echo. Last year, we working here for the field observation, just 12 days. With the 12 days, I will have a chance to introduce the following recognition of the tectonic framework of Sumatra. Next. And here, of course, as a geologist, we can go everywhere, not only for the work, but we can enjoy you glossary, history, and the splendid culture. This photo is from the Museum of the Canberra. Next, please. Of course, and we can see very, very beautiful scenery of here. Next. Of course, it's delicious food. Delicious food of the Sumatra or Indonesia. For me, I cannot separate it very well. Perhaps for you, it is different. Like Chinese, the plate of the Shanghai and the Sichuan is quite different for me, but perhaps for you, a little similar. Okay, next please. And I never, before I go to the Sumatra, I never think about the Sumatra is a very, very huge orogenic belt. From the view of the lens, it is equal to the Himalaya. It's almost 1,700 kilometers in length. So this is meaning you have a very, very huge orogenic belt. Next, please. And before we present our work, I would like to introduce the previous work, how they considered the Sumatra. From you, I just introduce briefly, perhaps you have already known it. From the view of the tectonic unit, Sumatra can separate 4 units: Eastern Sumatra, Western Sumatra, Walla Naip, and Accretional Wedge. West Sumatra have, from the view of the stratigraphy and the paleontology, the fossil have Spermasu affinity. Spermasu, perhaps the name a little special, a bit special. Si is meaning Siam. Siam is Thailand now, and another name in part of the China also. And Bu, this is not a good name. This have a name like colonize. Now we call it Myanmar. Before, in English, they call it Burma. The Burma is meaning West Myanmar. So we call it San State also. And Ma is Malaya, not Malaysia. It's Malaya. It's meaning peninsula of the Malaya. Su is here, Sumatra. So here is, there is a block from the Tibet plateau, just prolongated here. Of course, there different people have a different opinion about this. And Western Sumatra block, this is have a affinity of Indochina block. Indochina is meaning Laos, Cambodia, and Vietnam. There is a little part of China is Yun province. And here you will find the southern part looks like affinity to the northern block, but the northern part of the Sumatra looks like quite similar with the Malaysia or Malaya Peninsula. So this is the meaning. We must move the West Sumatra to the northern part someplace. And this is the meaning we have 2 very important tectonic zone or tectonic land. The black is Media Sumatra Tectonic Zone, MSTZ. This is meaning it is plate boundary between the east and the west. It is related to Paleothetis, Mesothetis, or something like this. And another is Sumatra Strict Slip Fault. I didn't say too much because Professor Chu Yang will introduce in detail. Next, please. And the most important, for example, like here, Banda Aceh is not so far at the MSTZ. The MSTZ is expressed by the melanite, gneiss, and schist. And from the view of the structure, it is dextral, is meaning right strict slip. Dextral strict slip shear zone and make the West Sumatra slip from the Indo-China block for at least 1,700 kilometers to its current location. Yes, it's meaning now. And this interpreted the difference between East and West block. This is the boundary. And from the view of the tectonic, it is involved paleo or neotectonics. And but from this map, you can find it is introduced by the late Triassic granite. Even we can cite it is plate boundary, but we cannot find no ophiolite and no suture zone. It's just a fault zone. Okay, next please. And this is a progressive of our research. This progressive is the result of the group. My institute, IGG, and IVPP we work together. And our field work concentrated at the southern part of the Banda Aceh district, A, B, and C area, more or less at the central Sumatra. And with this field observation, we can separate the different phases of the deformation, D1, D2, and D3. At least the 3 phases of deformation have a separated. Next, please. And here we have A, B, C cross-section past this A, B, C area. And the most important is D1. It's indicated in the metasedimentary rocks. Generally, you call it is the basement of the East Sumatra or West Sumatra. The significant feature is northeast, southwest mineral and stratigraphic lineation. And along this lineation, we can find top to the northeast sharing or top to the northeast kinematic. And this is very important or significant tectonic event. Is meaning there is deformation from southwest to northeast. I would like to mention that here I have already put the MSTZ in the cross section, but it looks like they didn't have a function very well. They didn't separate the deformation. The deformation in the eastern part and the western part is same or almost continue. And the second B is more or less concentrated in the brown color or brown yellow color is D2. This is the lineation is northeast southwest is similar with D1, but the kinematic is to the southwest, is opposite. So this makes us to separate 2 phases of the deformation. At the same time, from the view of the geometry, and we'll find the Walla nape or Walla group is located on the West Sumatra block. So this is meaning this is the upper part. The West Sumatra, the basement is in the lower part. So we need a deformation to the northeast. This is the region we can find the D1. And the C is much easy. It's just a boundary fault of the Oligocene and basin. And this is top to the south normal fault. Okay, next please. And here I introduce in detail, for example, East Sumatra. This photo indicated northeast southwest mineral stratigraphic lineation, and here the pressure shadow indicated top to the northeast kinematic. Under the under part, you can find the lineation also, and the kinematic to the northeast also, but the upper photo is belong to the East Sumatra. The under photo is belong to the West Sumatra. Its meaning, no matter east and west, lineation and the kinematic is same. Its meaning the geometry and the sharing deformation is quite comparable or similar. Okay, next please. And here is the D1 in the Walla group. No matter in the field observation, the scale of the hand sample, or in the thin section, all is to the southwest. So it is meaning the divergence is very stable. It's quite stable. Okay, next. And the D3 is a listic boundary fault indicated a clear extension deformation. And this extension deformation fabric the fault arc basin along the southern part of the coast. Okay, next please. And another is the some progressive on the view of digital zigzag. This data is from the Xu and Xiaoran. He is here. And Lai is more like the group of the Chong Sun Lin, the group of the Taiwan. He working here more than 10 years. And here, next please. Okay. And here just some consideration. I think it is not quite important. There are several peaks, but the most important is the significant magmatism or volcanism is 52 million years. And this period, magmatic or ignorance work or magmatic works, you can find not only in Sumatra, but also in Tibet. For example, Gandhi's arc have this age also. So another is the early Eocene is around this area. Is very short time from the 48 to 56, almost 17% of the zircon is come from this period. This presenting here's the population over a very, very short period. So here is very interesting. This is the meaning. During a short time, there is an eruption of the volcanic rocks, and there is intrusion of the granitic rocks. Okay, next please. Next please. Okay, and the most important, I would like, how about the eastern Sumatra and the western Sumatra? It's rarely can separated into two parts, but from the view of the digital zircon, I didn't have so many data at the western Sumatra, but the eastern Sumatra is okay. But you can find there are highly correlation between these two blocks. So from view of the digital zircon to separate the Sumatra into two blocks looks like unlikely. Its meaning this remains open to debate. Of course, there is a little different. I have noted in the western part there is 360 million years peak, but in the eastern part, no. But in eastern part there is a very weak 430 million years. So there is small peak, but in the western part they have this signal, but they didn't form a peak. Okay, next please. And we would like to know how about the Sumatra comparable with the regional block. And from the view of this, looks like more similar to West Burma. Is meaning Western Myanmar is western part of the Irrawaddy River, and then followed the second similar, or then followed by the Sumasu block. Okay, next please. So conclusion, and here is more or less the model or our understanding of the geometry. The very important things is there is sharing deformation to the northeast in the, no matter in the east or west Sumatra, and then the Walla Naip or Walla group located on the basement of this West Sumatra. MSTZ, I don't because I didn't have observed very well. The outcrop is quite limited along last year the road of the way observation. I'm not sure how about it is. And then at the last, the Fall Arc Basin forming given the D3 deformation. Okay, thank you. Thanks for your attention.
Thank you, Professor Wailin. You stand there or sit
I prefer stand
Okay.
here, and if the students or my colleague ask, have some comments.
Okay, sir. Okay, thank you for giving such an informative, interesting presentation about the new insight about tectonic frameworks in Sumatra Island. Okay, now come to the question and answer session. I open two participants. Okay, first in the back. Mention your name and your major, please.
Thank you for the opportunity. Let me ask myself once again. Good evening, sir. My name is Amran Sari. Mining engineering student in Faculty of Engineering in Kuliah University. Specifically, from years of 2022. Thank you about the meaningful knowledge. And just now you have explained about how Sumatra Falls was formed and how it start. And my question is, my question is, what tectonic processes are dominant in form the main geological structure in Sumatra?
Mean geological.
What tectonic process are informing form the main geological structure?
This is very good question because I didn't have so many geochronal results. But from the view, sorry, please continue. I find perhaps you didn't
in
finish.
Sumatra. And because Sumatra is an area crossed by the Ring of Fire, does current magmatic activity have the potential to support an existence of REE in the future? Okay, I think that's all about my question, and I'm sorry about my pronunciation is bad. And I think that's all, and thank you. Big thanks about your knowledge.
Okay, thank you. Thank you for your question. And yes, you raise a very good question and problem because I didn't have so many geochronal results to. I just separated the D1, D2, and the D3, and I have no idea about the age of these three facets deformation. For D3, it's okay because they control the basin forming is Oligocene or Eocene or Oligocene. So because all the deformation is brittle, there is no new mineral. So we cannot date it by the agon-agon or Johannine plan. So just by the stratigraphy, I think it is Eocene or Oligocene. And for the D2, because it is in the Walla Grove, this deformation should be after the late Cretaceous, because the youngest Walla group have the age of the sedimentary is late Cretaceous, so the deformation should be later. But before the D3, this meaning from the 90 to 50, between the 90 to 50 million years. And the most difficult is D1, because D1 is just in the so-called basement of the East Sumatra and the Western Sumatra. So I don't know the age exactly, but because the Walla group located on the Western Sumatra block, this is, but in the Walla knife there is no deformation of the D1. They just keep D2. So it's meaning this deformation should be around 90 million years. For me, I prefer when the thrust of the Walla on the Western Sumatra and make the deformation of this top to the northeast sharing. So it is relative.
How clear enough or already satisfying your vision? Enough? Okay, Professor. Any question? Okay, maybe only two from on the front. Please, microphone please.
Okay, Assalamualaikum warahmatullahi wabarakatuh.
Mention your name and your major.
First of all, let me introduce myself. My name is Astika Nora, and I'm from Geological Engineering Study Program. Professor, we already know that there is so high potential for megathrust earthquakes in Sumatran fault zone. So my question is, how can integrate the tectonic framework research result can be linked to the geological disaster mitigation? Maybe that's all my question. Thank you very much.
I didn't catch your question very well. You meaning the tectonic and the resource? Like earthquake, like climate change or volcanic eruption? Yeah, yes, it's a very good question. Perhaps please come back the detrital data. Go back. Okay, next. Okay, this one. This disaster, for example, the earthquake is happened now. It's not have a history of this how to say geological history, because there is the strand accommodation we need the time. But the earthquake is quite short comparable to the geological. So it is more or less we call it active tectonic. Have almost this is because of subduction and strictly fault and gave this. Of course, you need very, very detailed field work and analytical work. But I don't know in detail how to work. Like this is not my research domain. And the second, you will find there are several peak of the from the view of the detrital zircon. You have several peak of the magmatism or volcanism, the zircon indicated. So generally it is 0.36 million years. It's quite old also, but it's not meaning. For example, Toba, the super volcano Toba, this have influenced the global climate change. So this is quite important. to understand why there is a super volcano in Sumatra is quite important. Of course, all the people know because of the subduction of the Indian Ocean, because the crust of the ocean rests on water, and during it is subducted, and the water will go back to the surface and forming the volcanic rocks and the eruption, and this will change so many the environment, the climate change. Yeah. Thank you.
Okay, Professor, we have one more questions. Can we continue to the question session?
Yes.
Yeah, okay. Okay, please the microphone. Mention your name and your major.
Baik, Assalamualaikum warahmatullahi wabarakatuh. Mohon maaf sebelumnya untuk Ibu Nazla karena kemampuan bahasa Inggris saya kurang mumpuni. Jadi saya mengajukan pertanyaan menggunakan bahasa Indonesia. Jadi saya dari Teknik Geologi Universitas Kuliah. Pertanyaan saya adalah apakah perbedaan geodinamik antara Cina dan Sumatera apakah memiliki kesamaan tertentu? Sekian, terima kasih.
I repeat first. Yes. Apakah perbedaan geodinamik Cina dan Sumatera benar? Baik. Okay, Professor. The question is, what the difference between geodynamics in China and Sumatra?
This is quite a huge question, and because China is a very big country, and the eastern part and the western part is quite different. For example, in the western part of China, you can find the Tibet Plateau, Himalaya, and Kunlun, and Karakorum, the mountain, and you will find highest mountain in the world along the Himalaya. So this, from the view of this geodynamic, is similar like here. Is the collision between the India block to Eurasia continent and forming this huge mountain and the Tibet Plateau. But in the Western China, it's quite different. From the view of the geodynamic, it is Pacific plate, oceanic plate, and the Philippine oceanic plate subducted to the northwest. And during this subduction is formed the arc, magmatic or volcanic arc, is similar like this, but from view of China is different. And this arc formed like Japan, Ryukyu, and Aleutian. And this is meaning back up there is extension. This extension can rift the oceanic plate like South China Sea and like Okhotsk Sea and Japanese Sea. They have oceanic. This meaning have an extension structure. So this is the meaning in the eastern part of China. During this time, more or less extension, tectonics. The geodynamic is even there is two different plate subduction. But in the eastern part, the tectonic is more or less compressive. But in the eastern part is expansive. So it's very good question. These two parts is from view of the geodynamic is quite different. Okay, thank you.
Okay, is the question, is the answer is clear enough? Yeah, basically, China and Sumatra has different geodynamics, tectonics, yeah. And maybe you have to understand first for Sumatra tectonics, yeah, before to China. Okay, Professor, because of our limited time, so we'll continue to next session. Give applause first for the Professor Waylin.
Thank you.
Okay, thank you so much, Professor, for very interesting insight, yeah, about tectonic in Sumatra Island. Okay, the next session, we'll talk about tectonic evolution of the Sumatran fault synthesis and perspective. We would like to invite Professor Yang Chu to the stage. Please see. Before we start the seminar, I'd like to read the curriculum vitae of Professor Yang Chu. Yeah, he's currently as the professor at Institute of Geology and Geophysics, Chinese Academy of Sciences since 2023. Has received his bachelor degree at Department of Science, Nanjing University, doctoral degree at Institute of Geology and Geophysics, Chinese Academy of Sciences, and joint education for PhD in Department of Science, Orleans University, joint education for PhD, guys. He reached his postdoctoral to professor at Institute of Geology and Geophysics, Chinese Academy of Sciences, and being visiting scholar Durham University in 2018. He was awarded and honored for excellent doctoral dissertation, Chinese Academy of Sciences in 2013, Youth Innovation Promotion Association, Chinese Academy of Sciences in 2019. He also has some supported projects from 2013 until 2022 that related to tectonics in China and Iran, with the latest one funded by National Natural Science Foundation of China. It's like di kita mungkin Kemenristek yang sekarang digabung dengan Kemenristek Dikti, ya, biasa memberikan dana-dana hibah riset untuk beberapa riset-riset termasuk riset dosen, ya teman-teman ya. He has already actively published several publications for international journals with the in 2024 related to a synthesis of Cretaceous extensional domes in South China block. It's really interesting, yeah? Without further ado, welcome to the speaker, Professor Yang Chu, to deliver his presentation. Professor Yang Chu, the time is yours.
Thank you so much for the host of my CV and my presentation. Sorry, I just here waiting for my slide. Yeah. Sorry, I don't speak Bahasa. The most used word is nasi goreng and ayam goreng. Now I know ikan goreng. Yeah, I'm going to talk about the Sumatra fault. And yeah, because last year was my first time in Sumatra and also in Indonesia. So I just give some synthesis and perspectives and also maybe a little bit of geochronological data because it's still ongoing in our lab. This next slide. Yeah, my talk will have 5 parts, and the first is introduction. This next. Yes, first my thanks to leaders, the leader from Dr. Ling and from Dr. Yuan Setiawan, because Ling had just provided the money to come to Indonesia, and Dr. Setiawan provided the opportunity to come and have the chance to visit Indonesia and especially Sumatra. Yeah, here is my first slide of the talk. It's about the subduction system. Yeah, just like one student asked, what's the big difference between geodynamics in China and in Sumatra? The first one I would like to say, there's no such huge subduction system in China because most convergent system or origins in China are collision. So there's no such good target or no such good place to study the subduction system. And we know the subduction system has a lot of arc volcanism and earthquakes, of course, mineralization. And that's why we study the subduction zone. Is next. Yeah, why Sumatra? Because there's so many subduction zones around the world. And what makes Sumatra special? Because we know around the world, some researchers has make a summary of the subduction zone, the obliquity of the subduction zone. That means there's a figure that there's only 10% of the global subduction zone are also, it's just straight, just the subduction direction is perpendicular to this trench. And 90% of the subduction zone, of the subduction direction is oblique to the subduction zone. And here in Sumatra is a very typical region to study the oblique subduction system. And it has so many volcanoes, active volcanoes, and of course active continental Straxley fault, the Sumatra fault. And we can understand more about the subduction, oblique subduction, and the volcanism and continental deformation system. Is next. Yeah, this is my topic, the Sumatra fault. Sumatra fault is a Straxley fault in the overriding plate. And because of the obliquity between the Indo-Australia plate and Eurasia plate, so most of the movement of the oblique movement, parallel to the trench is accommodated by the Sumatra fault. And now from the figure in the right, we can see Sumatra fault is not a lonely fault because it's connected to the north with the Andaman Basin. It has already extended for like 10 million years. And to the north is the Sagan fault. We know the Sagan fault just had a very large earthquake last year and just caused a lot of casualty. So this Sagan fault and Andaman Basin and Sumatra fault just like is now forming a new plate boundary. Maybe it's just give some view of the formation of the new continent block. And please go next. So I just give some questions, not only for you, but for myself. What is the basic structure of this fault? First, of course, to understand the structure, we need to know the geometry and the kinematics. And then, what's the role of the Sumatra subduction in the Sumatra subduction system? Because we know there are so many volcanoes and so many earthquakes. So I want to talk about something about the tectonic magmatic interaction. And then, what's the tectonic history? I'm a structural geologist, so what I want to understand more is the tectonic history. What's the initiation time and the formation and how it evolves of this Sumatra fault. This next. So the next part is geometry. Yeah, we know this is a brief summary of the Sumatra fault. It's over 1,900 kilometers long dextrous Straxley fault just located within the overriding plate. And it's almost parallel to the trench. Tectonically, it can be divided in three domains. The north part the central part and the southern part. And of course, from the seismicity view, it's a highly segmented. Basically, from previous studies, it can be divided into more than 90 segments, and most earthquakes just occur within these segments. Almost, I think most of the earthquakes occur in, but only very limited earthquakes just cross these segments. Please next. So the previous, this is a very old study because at that time in 1991, it just gave very limited data of the GPS. And this data just show the GPS velocity from south to north. It just increased. In the south part, you can see the velocity is only 5.5, and to the northernmost part is almost 38. So maybe 6 to 7 times of the faster than the southern part. But please next. But with some new data, they have a lot of recent GPS observation, and from Bradley in 2019 and Natavi Jaja in 2018. They both are co-authors in the paper 2017, and they found that actually the recalibrated data showed the Sumatra fault move in a relatively uniform rate, about 15 millimeter a year. So this new data just give us a very new view of this fault, because if the fault move in a uniform uniform rate, so this size of between the Sumatra fault and the trench, showing that this part is a relatively rigid block. It just moved in a whole way. So this tells us maybe the Sumatra fault has become it's not like a nascent fault. Maybe it's just become more mature during the evolution. And just like the St. Andrews fault, it has moved and give a lot of earthquakes. Please go next. And about the offset, in early view of this, people think maybe according to because it's connected to the Sagan fault and the Andaman Basin, so maybe the earliest estimation of the offset is more than 400 to 500 kilometers. But actually, from some geological observation, they show, especially the offset of the rivers, they show the largest offset is less than 25 kilometers from north to south. And actually, there's no clear evidence for this scale. Because, sorry, the figure is not clear, but you can see the conclusion of this work. So I think that actually the total offset of Sumatra fault maybe is not very large. It's only about 25 kilometers. Please, next. So, talk about after talking about the geometry and kinematics, and then I want to talk the topic everybody wants to understand, the tectono-magmatic relationships. Yeah, here is a tectonic sketch map. We can see from the figure in the left, the most active volcanoes just located along the Sumatra fault. That gives us a very strong impression that most volcanoes develop because of the Sumatra fault. But actually, when we take a close view of it, we can see the Toba crater in the right is not very clear, but it's developed north of the fault. So there's two kinds of views of the volcano and the fault interaction. So which one is the boss? Let's go next. The first viewpoint is, of course, magma controls fault. There's some GPS or geodetic evidence to show that in the north segment of the Sumatra fault, as showing the profile A, you see the shallow seismic creep is only about 7.3 kilometers depth. But the southern part in the profile B is almost full locking. So that means the southern part maybe has more hazards when the fault moves, and the northern part, because there's something control the rigidity or the material of the fault, so it's almost show a seismic creep. In structural geology view, it's just a ductile deformation. Please go next. And some people think there's more volcanoes in northern part. For example, in the left figure, Lai has provided there's a lot of very young volcanic bodies in north. It's even less than 0.3 million years ago. And to the right, there's some geophysical evidence. There's VPVS values, because we know in more liquid words, the S wave cannot transfer in the liquid or in the melt. So high VPVS value ratios means there's more melt fractions, and that means this figure shows that the northern part of the Sumatra fault has more melt fractions. So that means the northern part has maybe more volcano, or maybe more or larger magmatic chamber there. So based on these geophysical and geological observations, we can see the magma in placement just reduce the fault strength, and that's why in the northern part the fault just move, because there's more fluid and more temperature. It's move like in a ductile way with a seismic creep. But in the southern part, there's less magma, so it has totally locking and has more seismicities. This is the first viewpoint, and the second one is fault controls magmas. And there are some researchers just doing statistical analysis of the faults and volcano distance. From the right figures, we can see they just calculated the 48 volcanoes, and almost 54% of is within the 10 kilometers of the Sumatra fault. So that means they're showing very strong connection between the faults and the magmas, and only almost 27% of them just located in the extensional step overs of the Sumatra fault. So that means the fault has a very strong controls on the magmas. Please click again. Yeah, that means during the deformation of the Sumatra fault, part of the extensional zone just associated with normal faulting. Just give the space for the volcanic activity. So that means the fault controls the magma. But of course, this is just a chicken egg problem. Nobody knows which has more controls on the other. So we need to have more geophysical observation, and that's what the larger projects want to do. Just give some seismic observation and seismic data to show what's the exact image of the underground. Please, the next. And the fourth is the key of our study, the tectonic evolution. Please, next slide. Next slide. And to answer just as I mentioned, the three questions initiation. So when was the Sumatra fault first movement, and then the formation? I want to know when did the Sumatra fault just cut the entire Sumatra island, just so they form the current architecture, and then the evolution. So what's the tectonic model of the Sumatra fault? Next, and here there's some, of course, some tectonic estimation of the Sumatra fault activity. The first one is if the Sumatra fault is linked to the Andaman Sea, so it must act like as the transform fault of the Andaman Sea spreading center, and the Andaman Sea basin has a very precise date of the sea basin extension. So the estimated initiation of the Sumatra fault may be older than 11 million years ago. And the total displacement may be 460 kilometers. But of course, it's a little tricky about total displacement. And if we just calculate from the south, Sumatra fault just connects the Sunda Strait, and previous work has also estimated initiation because there's some extension of basin there. So they think the Sumatra fault may be initiated at about 5 million years ago, and the total displacement is also larger. There's some previous estimations. Please, next. To truly give the precise time constraint of the Sumatra fault, for structural geologists, we want to do some low temperature chronology. It can give some direct date of the activity of the Sumatra fault. So there are two methods. One is apatite, uranium, thorium, and helium age. The temperature is a closure temperature. With a closure temperature, we can calculate, as the right figure show, we calculate the activity in different level at depths. The apatite, the AHE can give the activity at about 3 or 4 kilometers depth of this Sumatra fault, and the zircon CHE age can give maybe older. If there's some activity in the deeper, and just assumed by the fault activity, we can have some data about it. Please go next. And Professor Wang has from China University, they just gave a direct date on the Sumatra fault, and they are dating a very, for me, it's perfect. It's within the fault zone, all the AHE, I mean apatite, helium age, showing that the rapid cooling or rapid exhumation is occurred less than 2 million years ago, and outside of fault zone, the age showing that we call the old cooling history. And this apatite helium age also consists with the zircon helium age, and showing an age around 10 to 6 million years. So that means maybe during the activity of the Sumatra fault has several episodes of the fault activity. Let's go to next. However, he proposed a model to be tested. I mean, this to be tested because he has provided some data, but it's a little limited. He thinks the Sumatra fault didn't initiate before 2 million years ago, because he thinks all the apatite helium age showing the connection or showing the initiation of the Sumatra fault, but the older ages just showing early maybe compression. And before, too many years ago, the oblique convergence is just accommodated by other structures like the Western Andaman Fault and the Java Fault is in front of the main Sumatra Island. So during the later Miocene to Pleistocene, the deformation or this just propagate to the more northeastwards and into the mainland of the Sumatra Island. Please go next. And last year we have collected some samples, yes, trying to understand a more clear view of the Sumatra fault activity. We have collected some samples, and along the fault, they also give some good age, about 2.5. This is input as consistent with the previous work. That means maybe there's a regional activity or regional faster movement of the Sumatra fault. And we also get some older ages, like 4.79. And please go next. And we also do in a profile, we can see in the right figure, there's a aging trend of the ages. From near the fault, it's 30 million years. And when we go to far from the fault, it's just move to maybe 19 or 14 to 19 million years. So maybe there's some differential information of the basement. And so based on these ages, I want to give some summary to the next. Yeah, so to answer the question, when was the Sumatra fault first movement? For me, too many years, maybe it's too young, because maybe it's just record a faster movement of this age, but not the initial timing. I think there's more age around 15 to 10 million years ago, so that may be some early movement or maybe initiation, but that needs more data to confirm it. The formation, I think, is highly segmented, but maybe the different parts just has a different activity timing, but I think maybe the 2 million years ago is a total connected age. And for the evolution, some people just show that it's firstly it's a thrust and then struck sleep, but with not too much work and not too many data, so I just leave it as an open question for my talk. Please next. So go to the conclusions next. I just skip it. Just give a quick. I just highlighted with some of my synthesis, and it's highly segmented, and I think the sleep rate is about 15 millimeter per year, and the total offset is 25 kilometers. And there's some chicken egg problem about the faults and the volcanoes. For me, I think both have a very strong effects on each other. Please go to next. And yes, to get a more clear view of this Sumatra faults, I think more field work, and that's why we're here. We want to observe more and collect more samples to do the low temperature thermal chronology, and then give a better time constraint of the fault evolution. Of course, another part of the project is to do the geophysical imaging of this part, and with some high resolution data, we can get a better result of the deep fault structure. And yes, there's still a lot to understand, but we need to go little by little to understand more about maybe the hazards of the Sumatra fault. Thank you.
Give applause to Professor Yang Chu. You want to answer the questions standing there or
Yes,
sit?
just standing
Yes, okay. It's very interesting because after I see one illustration about the Sumatran fault that continues to Myanmar, it just reminds me about the earthquake in this earlier year. In this earlier year, as you know, it related to Selimum fault. And one of the geophysicists lecturer here in just give a seminar and say that there's a correlation between the Sumatran fault with Myanmar earthquakes. Yeah, I just see the illustration here. Okay, we come to the answering question session. We give 2 questions. Okay, for the black shirt first.
Assalamualaikum warahmatullahi wabarakatuh.
Okay, never mind. Mention your name and your major.
So my name is Angel Jessica. I'm from geological engineering student. So my question is, from a tectonic perspective, how might the evolution of the Sumatra fault provide insight into the border dynamic of oblique subduction zone globally? Thank you. That's my question.
Okay, you got the question?
About I think the importance of the Sumatra subduction zone, right? Yeah, because just I mentioned at the first Sumatra fault, Sumatra subduction zone is a oblique subduction zone, and for me, why is it important? Because everybody knows the 2004 earthquakes, and the Marseille and the Sumatra Trench earthquakes. They're just so large and attracts so much attention from the world. And of course, the trench is very important, but for structural geologists, the inland deformation is also important, and it has a very large. I mean, for me, for other geologists, it's like a strike-slip fault, Sumatra fault, but maybe it will evolve to a transform fault, just like the San Andreas fault in North America. And yes, here there's volcanoes and earthquakes. So with such kind of oblique subduction, how this geological hazards can be connected with subduction dynamics, it's really a very important question to maybe to understand this subduction zone, and of course to understand the evolution of the Sumatra faults. Yeah, for me it's really important because it has a lot of earthquakes, and maybe it's sometimes ignored by the geophysicists because they like more the megathrust earthquakes. They like the earthquakes in trench, but the inland, just like in China, actually most large earthquake caused a lot of casualty, like 2008 the Wenchuan earthquakes, which killed over 50,000 people, and it's also intracontinental fault and part of the strike-slip fault. So to understand the evolution of the strike-slip fault, especially in these convergence zones, maybe just help us to understand the evolution of such a large faults around the world. It's just maybe give us so much information about that.
Okay, is the answer satisfying you?
Yes.
Okay, thank you. Maybe we can say that each plates correlate to each other, yeah?
Yes.
If we learn one, and we can learn the other plates that's connected to its surroundings. Okay, the next question. Okay, the black one. Lebih tadi salah ya, harusnya yang baju hitam ini tadi. Mention your name and your major.
Thank you. My name is Raja Fidras Ali. I am a undergraduate student from Kuala University. My major is geophysics engineering. So I heard from your presentation just now that you take Sumatran fault as your research topic, right? So my question are, the first one, did you find something interesting or unique from this Sumatran block? And the second question is, does that unique thing affected from the tectonic activity or tectonic evolution from the past? Maybe that something interesting, I mean, like the animal, plant, or maybe the mineral potential. And that is my question. Thank you.
First one is about something interesting about the fault. Yeah, of course, the most interesting thing is the earthquakes. Here is a very large seismic active fault. So with this kind of active fault, we can, with collaboration between geophysics and geology, we can understand more how a fault can form earthquakes. In this region, for example, we have volcanoes. So just as I talked, there's some relationship between the volcano. Volcano can provide fluids, and if we have more fluids, make the fault weaker, and it can easily generate earthquakes. Or maybe some with more fluids, we just weaken the material, weaken the crust so much, it just generates a seismic creep. And there's some link, but the link is still unclear. So in the earthquake mechanism is still a very hot topic around the world. So this area just gave us such a good chance to understand why there's a large earthquakes and why there's a large volcanoes. So with this connection, it will be a good opportunity to study this. And the second one is about maybe the mineralization and some economic geology. Right? Yeah, here we know there's a lot of mines maybe near the volcanoes, and we always, if we study the mineralization, we know the mines always, the elements are always transfer within the fluids. And the fluid, if we want to get fluids, and the fluids must just move along the faults. Only these faults, they'll give space for the fluid or maybe magma replacements. So that's why along the Sumatra fault, only in extensional parts or segments, there are more volcanoes there. So if we can give a very detailed mapping of the faults and the fault types, maybe we can connect it with and try to find more mines there, because that's very helpful even in some tectonic complex regions. We always want to find how the fluids move along the faults and along which kind of faults.
Okay, clear enough? Okay, thank you so much, Professor Chang Wu. Give applause for Professor for interesting presentations. Okay, for the next session, maybe the last one, we'll answer your question. Please, the black shirt, it will answer your question why we talk about fault today, because it related to magnetic system. And please welcome our last speaker, Professor Xiaoran Tang. Please come to the stage. This our last session. We'll talk about magmatic system, right? Magmatic records of Sumatra. After we talk from Professor Wei Lin about kinematics of tectonics in Sumatra, and then how its correlation to magma with Professor Chang Wu, and then the last one we talk about how the magmatic records of Sumatra. Okay, before we start, I'd like to read the CV first. He's currently as the associate professor at Institute of Geology and Geophysics, Chinese Academy of Sciences since 2021. He has received his bachelor degree at geological major, Nanjing University, taken master degree at Institute of Tibetan Plateau Research, Chinese Academy of Sciences, and doctoral degree at the University of Hong Kong in petrology major. He started his career as research assistant in the University of Hong Kong, then taken his postdoctoral at Institute of Earth Sciences, Academia Sinica, and associate professor at Institute of Geology and Geophysics, Chinese Academy of Sciences. He was awarded and honored for high-level talents of the phonics plant in Chaoyang District, Beijing in 2023. He is also currently involved in some projects funded by National Natural Science Foundation of China and talent project of Chinese Academy of Sciences in range from 2022 until 2026. Yes? Okay. So many publications and without further ado, welcome the speaker, Professor Xiao Rantang, to deliver his presentation. Professor, the time is yours.
Okay, thank you for this event introduction. And first, I should give my special thanks to Dr. Iwan for giving us the opportunity to visit Sumatra this year and last year. And as we can see, the title of my talk is Magmatic Records of Sumatra, which is only 4 words. And as compared to theirs, it's quite short and simple. So I will try my best to make my talk short and simple. Because I just realized several hours ago, most of you students are from the Department of Engineering. So maybe some part of the presentation are hard for you to follow. So I will try my best to make it as simple as possible. So the talk is about the magmatic records of Sumatra. I'm Xiao Yanzhang from the IGGCS Beijing. Okay. This is the outline of my talk. And first, I will give you a brief introduction of Sumatra, which just tell you that the data are from Sumatra. And also, the second part will mainly focus on the published dating results of Sumatra from the perspective of tetrahedral records and some other dating methods. And finally, I will present you some our new dating results. Because these new results, we just got these results in the last week, most of the data. So we don't have any detailed conclusions at present. So next. And this is a brief introduction of the Sumatra. As we all familiar with the Sumatra, it's divided into these 3 tectonic zones and 3 tectonic units, and separated by the middle Sumatra tectonic zone. And next. And this on the left is a summary of the strata existing in Sumatra. And this is from the book of Barber in 2005. And we can see from the bottom, there's no record of pre-Cambrian basement in Sumatra. And also there's very little evidence of old, such as lower Paleozoic to Devonian records in Sumatra. So that means there's no records of magmatic records with the age of from pre-Cambrian to Devonian in the Sumatra. This is another photo showing the distribution of the magmatic rocks. You can see there are lots of Triassic and younger magmatic records throughout Sumatra. And all these Triassic and younger magmatism can be related to the subduction of the Meso-Tertius and the Neo-Tertius, and even the younger one, the Indo-Australia subduction. So these are quite simple. All these Triassic and younger rocks are related to the different subduction of oceanic plates. And the older ones, we are not sure, because at present, there were no record of the older ones. Next. So in the following, I will give a brief summary of the existing dating results from Sumatra. First, let's have a look at the detrital zircon records. On the left is the paper I published in 2019. It's a very simple figure to show you the location of the samples as marked by the black ones and red ones, red stars. You can see all the samples are from the whole island. And on the right, top right, you can see the summary of the dating results of zircons. And this is the age in million years, and this is the number. So it's quite easy to read. If you found these peaks, it means there's lots of such aged magmatic rocks in this region. So we can see there are several different peaks in Sumatra. So and they agree very well with the existing dating results of Sumatra. Okay. And as you can see, these are the zircons with age older than 250 million years, and the previous one is zircons younger than 250 million years. As I mentioned before, there's no record of Precambrian magmatic rocks in Sumatra, so let's ignore this part and just have a look at these younger ones, which is 215 to 500 million years. And we can see from East Sumatra, there's almost no the zircons within this range. But in the West Sumatra, you can see lots of them, and with a peak at this age is 350. So does this mean there's late Paleozoic basement in the West Sumatra? But we are not sure, because they are detrital zircons. We need at least one outcrop of magmatic rocks to confirm this. And in the following, I will show some direct dating results from the Sumatra. And this table is also from the Barber book, published in 2005. And on the right is a summary of the existing dating results at that time. You can see there are lots of dating results based on the argon-argon to potassium-argon dating methods. And also they form several different peaks, such as this is 215. Is agree with very well with the detrital zircon records. And we also see these 15 million years old peaks also have been found in the detrital zircon records. But we must mention that these are the results that are published before the 2005, and they use the methods of argon-argon and potassium-argon dating methods, and they are outdated, or they are not as reliable as the zircon methods. So we must need more data, particularly the zircon dating results, to confirm this. Next. And in the following, I will summarize the zircon dating results in Sumatra. And according to my knowledge, this should be the oldest magmatic rocks found in Sumatra. Sorry for this Chinese characters, because it's a paper published in one Chinese journal. And the sample is located here, close to the city of Takingo. And according to the zircon dating results, is Silurian over the age of 442 million years, and the geochemical data indicate they show the S-type granite signature. So this may imply the existence of Silurian basement in Sumatra. However, as I mentioned, this is just only one outcrop from here. So we need more outcrops to confirm this. Next one. And during the Triassic to Cretaceous, as I mentioned, there are lots of such aged magmatic rocks from the central part of Sumatra, and such as this is reported by the Professor Lee. They related to the subduction of the Meso or Neo-Tertiary Ocean. And also during the Cenozoic, there are lots of such aged magmatic rocks. You can see all these red and blue ones, they occur throughout this island. And these rocks may be related to the subduction of the Neo-Tertiary Ocean or the Indian Ocean. But that's one very interesting finding mentioned by this author, Professor Lai. He found magmatic gap during this 48 to 22 million years. But unfortunately, these authors did not give any particular reason for the formation of this magmatic gap. Next one. And these are the locations of the Cenozoic rocks. And as shown from this stage 1 to 2 to B, these are the changes of the locations of Cenozoic magmatism. Okay, next one. And in the Banda Yachi region, Professor Lai published several papers. In particular, this is one published in 2021. He found many melting rocks marked here. It's very close to the university. And you can see the ages varying from the 220 million years to the 16 million years, and very young is 0.3 million years. And from the different location, they argue that the different location of these rocks might be controlled by the opening of the Andaman Sea, which is very close to the Bandar, and or even the development of the Sumatran fault. And also, another group of researchers found one 8.7 million years old rock from which region? Also in the Bandar region. And the geochemical signatures indicate they are artifacts. However, they did not give any particular reason for their formations. Whether they are related to the opening of the Andaman Sea or the Sumatran fault or the subduction of the Indian plate, we are not sure. So we need more data to confirm or to further discuss about the formation. Okay, next one. And in the following, I will present some of our new results. These results are based on the samples we collected last year. And first of all, I will show you the most interesting ones is the 320 million years old Atacus. And the samples are located here. It's the red one. It's very close to the city of Padang. And just ignore these different figures. This just they show these rocks have the geochemical signatures of Atacus. And zircon UPV dating indicates they are 320 million years old. And as I mentioned, there's very little records of Carboniferous to Permian magmatic rocks in this region. So this finding at least indicates that's Carboniferous crystalline basement in West Sumatra. And next one. Also, which is located very close to the 320 million years old one. That's another one closer to the Padang city. We find it has the age of 275 million years. This also shows the Atacus signature. And which will imply there may be Permian basement in West Sumatra. Also, we found the later Triassic granites, which is located closer to the Simboga city, and they show the signatures of A-type granites. And also, ignore all these figures. This I used to prove to you that they show the A-type granite signatures. Okay, next one. This is a similar one, similar age, and similar rock type. Is located very close to the previous one. And also another one located to the south of the Simboga city is also of the same age and same rock type. So there must be a very large region of late Triassic A-type granite from this location. Okay. And also we found another one very interesting is of the same age is 216 years old, but it shows S-type granite signatures. However, the exact formation mechanism for this S-type granite we don't know. Okay, next one. And also, we collect one boulder from close to this Kota Faja city. It has an age of 135 million years, and also the geochemical data indicates it should be the S-type granite. But as I mentioned, it's just one boulder, so we maybe need to collect more samples from here. Okay, next one. And there are lots of using using granites from the Sumatra. For example, this one we found quite interesting because it's a local granite of the age of not previous one. No, down. Yeah, this one. It's because it's a local granite. This hasn't been found or reported in Sumatra. It's located to the north of the Toba Lake, and shows the age of 55 million years old. And this hasn't been reported from this region. Okay, next one. And also we found lots of this 53 million years old A-type granites, which will be or have been reported across this island. Okay, next one. Similarly, the same A-type granites from this location to the north of the Kota Faja city. Also, next one, we found very young A-type granite, probably showing the age of 16 million years. We don't know for sure the formation for them at present. Okay, this is a summary. Our new finding are the ages in blue. So you can see they mostly concentrate in the central part of Sumatra. So this year we plan to collect more data from the northern and the southern. From the northern and the southern part of Sumatra. And as you can see, all of these ages correspond very well with the detrital zircon records. For example, the 212, similar to this 216 million years old rocks. And also the 185 and 50 million years old 8 peaks have been found in the Sumatra. So next, so our main objectives of this year and after the field trip will be focused on the old rocks we found in Sumatra. For example, the 320 million years old and 275 million years old Atacans. We will do more analysis to make sure of the age and the formation mechanism and tectonic setting and magmatic sources to finally to constrain the whole tectonic evolution of Sumatra. Okay, that's all. Thank you.
Okay, give applause first for Professor Xiaoran Tang. really interesting about magma. And one thing that I always note about if we learn about magma is always correlated to geochemistry, right? And I think the research is quite pricey because most of the data is dating. Yeah, it's really
We just got data, most of the data in the last week.
okay. Yeah. Now come to the question and answer session. We open only two. Okay, from Mr. Rifkan, our lecturer. Please, microphone.
Okay, nice to meet you, sir. I already have one question that we already work in Chalang several time ago, and
You mean Java? Okay.
in
Java.
in Chalang, all right. And then we know that the Wela terrain as the youngest terrain that assembling Sumatra, and in Chalang, in regional Chalang, actually we find that the Wela terrain surrounded by granitoid batholith Sikuleh. The question is that possible that the terrain which is older than the batholith Sikuleh can in the middle of yeah.
Picture of Sumatra. I don't. I'm not familiar with the location. So can you show me on this map? Yeah. And are you sure of the age?
No, the geological map. That we found the Wela Park in the middle of the red one.
Yeah.
Yeah.
Oh.
Yeah.
I'll see.
So my question is, is that possible? Because I think the Wela is more older than Sikuleh, the younger complex here.
That's a map. Please. It's this upward.
Yeah.
You can see the age. Yeah. You can see the age. It's 60.5 million years old. So it's much younger than the Wela nape. Yeah. So it should erupt and intruded the Wela nape.
So the Wela is rootless, so it's just floating in the middle of yeah.
But probably in during probably in at 90 million years ago, as proposed by Robert Hall, the Wela nape thrust over the Western Sumatra. Yeah. So this granite is much younger. It's 60.5 million years old, and when the Wela nape was already on the western Sumatra. So this granite erupted and intruded the Wela nape.
So the Wela just floating. It's rootless.
What do you mean?
So the Wela part, the small part of Wela is just floating in the. Oh,
you mean on what? On West Sumatra? Okay. The relationship is very clear. They are much younger than the Wela. The Wela thrust over West Sumatra at a very old age. So actually probably 19 million years.
But there is no the trace of like the tracks dia numpang di atas gitu. Tapi dia di tengah-tengah saja.
The granite intrude. What? Repeat. No. It's intrusion. It's the granite into the boiler, I think. Such as. No, because the boiler is much older. And then maybe tectonic reasons, tectonic complex. Because the boiler is much older. And this rock is very, very young, it's 60.5 million years.
Okay. Maybe after this session,
Thanks, okay.
we'll see the map.
Okay, it's very interesting discussion. You can continue after this seminar. Okay, we continue for the last question. Yeah, on the back, please microphone. Mention your name in your major.
Assalamualaikum warahmatullahi wabarakatuh. Firstly, thank you for your presentation, sir. My question is, before that, my name is M. Abdul Malik Nainggolan. I'm from mining engineering, and my question is, we know that in Sumatran fault there is so many volcanic mountain, but the problem is why the volcanic mountain is not erupted at the same time. They are eruption at the separately time, even the source was from the same subduction zone. How it can be possible? Thank you.
You got the question?
Yes, I got your question, but I don't know how to answer that. Yeah, you know, the different eruption times are dependent on the underneath of the magma chamber. Yeah, it's erupted because of I don't know how to say. Yeah.
This is depending how you understand the time. It is geologic time over the person living time. Like Xiaoran and Chuyang have already introduced, the volcanic rock is measured by million years, but what we cite is year. So from the view of the geology, it is almost the same time. Because what we dating is a million years. Okay?
Is it enough? Enough, okay. Okay, because of our limited time for today's seminar and many questions maybe as in our mind, yeah, about Sumatra, and it just opened our understanding that Sumatra is one of the complex tectonic settings in Indonesia. Okay, guys. Oh, we have an applause first to Professor Chiao Chang. Thank you so much. Okay, ladies and gentlemen, we finally come to the end part of the seminar. Really interesting. Many students is really active to ask the professor and Bapak Iwan Setiawan I would like to thank the speakers, for informative, interesting presentation about new perspective and insight of Sumatra Island, especially the tectonic and magmatic system, and then related to mineral deposit distributed to along this island. Hopefully this seminar will be beneficial for all of us. Please give applause for the speakers and for you all, guys. Thank you so much. See you for the next seminar. Assalamualaikum warahmatullahi wabarakatuh.
Baik hadirin sekalian, terima kasih kepada moderator kita Ibu Nazla Syafitri Rangkuti dan terima kasih pula kepada seluruh pemateri kita baik itu dari BRIN maupun para profesor. Selanjutnya kita akan memberikan plakat kepada para pemateri. Next is the awarding of certificates to the presenters as a form of appreciation for the knowledge that has been provided. So, the first one is to Bapak Dr. Engineering Iwan Setiawan yang akan diberikan oleh Bapak Dr. Insinyur Gartika Setianugraha STMSI. Next is to Professor Waylin oleh Ibu Dr. Insinyur Halida Yunita STMT. The next one is Profesor Yang Chu oleh Ibu Tika Hapsari STMT. The next is Profesor Syauran Zhang oleh Ketua SMYG Muhammad Ilham Adiraya Parinduri. Dan untuk pemberian plakat kepada moderator mungkin oleh Ketua SMYG Muhammad Ilham Adiraya Parinduri. Baiklah, terima kasih kepada seluruh pemateri. Mungkin selanjutnya kita akan mengadakan sesi foto bersama lagi kepada para pemateri. For all the speakers, please welcome to the podium so we can take a photo together again. And all of you guys can join. Baiklah, hadirin sekalian. Baiklah hadirin sekalian, dengan selesainya sesi foto bersama, maka berakhir pula seluruh rangkaian acara kuliah tamu dengan tema Geodynamic and Minerals Deposit of Sumatra Island, Indonesia. Saya Musadiko Horirayana selaku Master of Ceremony mengucapkan terima kasih atas partisipasi dan antusiasme Bapak atau Ibu dan rekan-rekan mahasiswa sekalian. Mohon maaf apabila ada kesalahan selama memandu acara. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Teman-teman, tolong sampahnya diambil ya teman-temanku. Terima kasih. Tolong bertanggung jawab atas sampahnya sendiri. Terima kasih. Malu banget. Sini. Oke. Malunya. Bertahan.